Good afternoon again, one and all present here. So let's start the session now. And today we are going to discuss about the various wireless protocols and the scope of MRuby programming uh, and its application in today's technology. And I see most of you are from circuit branches, and we are already familiar about wireless technology, right? So uh, there are so many protocols existing, and it started its evolution from the late 1950s. So it is not a new technology, but it is the important technology without which we cannot connect over the internet or connect across the globe, right? So let us just quickly brainstorm. I would like you to answer, or I would like you to find and discover the existing wireless protocols. Actually, we are surrounded by various wireless protocols. If you could like just brainstorm what are the protocols that are used at present or that are surrounded by you. Can I'd be glad if somebody could unmute and answer at least some few protocols that are being used now, that are being used in your surrounding, especially maybe a few, one or two would be good. So I'm just asking this question just to relate, so that we can relate to coming slides easily. Okay. So yeah, there are so many protocols surrounded by us. For example, now we all have connected over internet, and you all might have connected over different Wi-Fi networks, and it is one of the examples of wireless protocols. And now we are meeting via Google Meet, which communicating over HTTP protocol, which is again a wireless protocol. So these are the simple and day-to-day protocols that we are using in our daily life for our communication. Also, now we can see, so we are just connecting globally, everywhere, anytime, using any device. So this became possible because of the advanced wireless protocols that are being implemented. Also, the communication between the earth and the space became possible due to these wireless protocols and the advancements in it. So yeah, these wireless protocols will stay forever with the advancements. So that's what we could say. So okay, let's see. So we already know about the wireless protocols, right? Let me just brush it up. So wireless protocols are nothing but a set of rules and some standards that governs how device communicate with each other without any physical cables or wires, right? We are just communicating over internet through air as the channel, right? So these protocols are very essential, and they manage how data is sent, how data are received and interpreted over the air. So this ensures that different devices can connect and interact smoothly. So now let's see how these protocols basically work. So there are a few steps for the data to, go through the air. The first thing uh, in this protocol is the data packetization. Wait a minute. Yeah. So usually all the protocols that breaks down data into small manageable units, they are called packets, we already know it. And each packet have a certain information, maybe like the destination address or the original data sequences. So everything is chunked and embedded into multiple packets. So This is called data packetization, as we all know. And these packets will be modulated because we are communicating over air. So, and the data we are giving will be in the digital form. And for the communication over air, over the internet, we have to modulate these digital signals into the analog signals. So this data is converted from a digital signal into an analog signal, like the radio waves or light waves, etc. If you are using optical cables as the communication channel, then these digital data will be converted into the analog light waves, right? So then the transmission happens here. This analog signal is broadcast wirelessly using some specific frequency and specific power levels. So these will be determined by the protocol design. So we have several protocols. So each protocol has its specific frequency and specific power level. Yeah, based on which the strength and the use case of the protocol is defined. And we'll be having a receiver. So that receiver again captures the signal and converts the signal back into the digital data to just preserve whatever is sent from the sender. And then this reassembly phase happens as the final stage. So the device basically uses the information on each packet and reassemble the data in the correct order to recreate the original message meaningfully. Apart from these process, the protocol also should include the security aspects like encryption and other security protocols to ensure the data is being preserved, and also to minimize the data leakage, right? So now we are communicating over a secure HTTP communication. So if it is a confidential conference or confidential business meeting, so the data should be preserved, right? So the security measures also applied in such wireless protocols, any other communication. So we have multiple methods for it. We have to apply the encryption methodologies and some authentication mechanisms. We also ensure the less malware attacks or less data attacks while we are communicating. So these are the important aspects while we apply the protocols. And so now moving into the next, so why we use these protocols, what are the significance of these? Let's see. uh, we all know without these protocols we cannot communicate at all, because we everyone use multiple devices manufactured by multiple manufacturers, and the underlying operating system is different, right? We have Windows, Android, iOS, Linux, etc. Also we are in different topological region, with different geographies and with different time zones, right? So there should be a standard rules for seamless communication, uh, right? When we connect over internet, there should be set of protocols, and which should be standardized. Then only all the devices, irrespective of the underlying operating system or the underlying mechanisms, we would be able to connect over internet. Just think, if every OS defines their own protocols, then we cannot connect, right? So there lies the interoperability. uh, so these standardized protocols ensures that all the devices from different manufacturers can communicate with each other, as I said. So for example, we can connect our mobile phone, and we can just cast the screen of the mobile phone on the TV. So this is achieved because of the standardized protocols. So usually here we use Bluetooth, right, to cast over the devices. For example, if I have iPhone, I just cast the screen of the phone to my Samsung TV, right? Both the operating systems are different, but how this became possible? That is because of these standard protocols. Okay, just think, if I have Apple TV and if I have some Samsung or Sony TV, and if I don't have some common protocol or the standardized protocol, I won't be able to connect, right? I just again want to buy some Apple supported TV or like that, which is not feasible. Not everyone can afford that, right? So these protocols, these wireless standardized wireless protocol ensures the interoperability here. It also, this is very critical for building the diverse ecosystems. Uh, and the connectivity, so establishing connectivity, so these wireless protocols define the entire process of how devices find and connect or maintain communication with a network or other device. They can handle tasks like network discovery. For example, when we cast our phone over the TV, so it automatically searches the available network nearby, right? Or if we are connecting the Wi-Fi, or yeah, if you are just trying to connect all the devices over the hub, so it automatically searches the network availability. So this search is also facilitated by the set of rules that is being defined inside the protocol. And also here, authentication is one of the main processes. Like, we have to enter the password of the particular Wi-Fi network. That is where the security aspect and the authentication aspect comes into the picture. Then so yeah, these standardization of the protocols helps us to manage the data transmission. As we already discussed, these protocols, helps us to break down the message into a small and manageable packets with the destination address and whatever the vital information we need inside it. They manage these protocols, they manage the modulation, demodulation uh, processes. And this process is crucial for preventing data corruption, and this ensures the communication is happening reliably. And the other important aspect is security. uh, the main role of these protocols, these wireless protocols, is to provide security by protecting data from unauthorized access. Uh, we have certain encryption standards like WPA3 Wi-Fi standards that scrambles data and making it unreadable while communication happens, uh, without the correct key, right? So this is the crucial step to protect sensitive information such as personal data or financial data or the financial transactions. And also, the performance optimization plays a key role. We have to optimize performance over each and every communication, over each and every packet, sorry, when they are transmitted. So we have n number of protocols that are designed for that, for specific performance, for specific balancing factors like speed, the range we are connecting over, the power consumption for the entire system, it, like that. For example, if we speak about Bluetooth, it only supports the minimal range. For example, we just can connect over some 10 to 20 meters range over low energy Bluetooth protocols and all. So that is specifically designed for that. Okay, so these kind of low power technologies consumes low power, uh, because they are just communicating under a minimal range. So this ensures the lower power consumption and higher life of connectivity. So these are the important aspects that should be considered when we design a protocol or when we imply a protocol in the existing framework or existing system design. Okay, then moving to the next thing. So let's see how the protocols evolved. So earlier, so when we were just stepping into the wireless communication, there is something called Morse code. Most of you would have heard about it. So it is the It is not entirely the wireless protocol, but it Morse code follows set of instructions to communicate in the wireless medium. You mean the you know uh, so these Morse code were used over the radio waves. So when we were using radios, these Morse code uh, had been implemented, but it is not the entire wireless system, but it is the pioneer, or it is the start of the evolution of these protocols. And the radio waves, when the Marconi invented the radios, this was the first practical system of the wireless communication, which transmitted the signals over radio waves without any wires. Actually, it is specifically used for point to point communication, not for the wide range of broadcasting. And then there came the 1G cellular data in early 1980s. So this facilitated the mobile telephony, which primarily used the analog signals, and it is just used for voice calls. And have it had very poor security implications, and it also had heavy signal distortions and all. For example, we can say the AMPS, the Advanced Mobile Telephone Network System. So after these, in the earlier 1990s, the protocols, the wireless protocols, slowly got its standardizations. So like the evolution of, I think I can see someone is raising their hand. Do you have any questions, sir?
Somnath sir, can you have any queries? Sir? Okay, ma'am. We'll continue.
Okay, yeah. So we can assume that he might have, unawarely clicked the raise hand button. Okay. Now what we yeah the 2G cellular technology. So the 1G technology just facilitated the voice calls, where this introduction of 2G cellular network enabled us to text over the phone. So this introduced SMS, the text messaging. Also, it improved the security of the voice call and also the clarity of the call. The technologies like GSM and CDMA are the key examples of this 2G cellular network. So, yeah. And then came the emergence of Wi-Fi, the wireless fidelity technology. In 1997, it came. So it followed some, very standardized methods. So we can say this is one of the very standardized protocols. So that followed IEEE 802.11 standard. So this ensured the standard wireless local area networks. The earlier versions were too slow that it was able to provide just 2 Mbps speed, but it laid the basic groundwork for today's advanced Wi-Fi technology. And in 1999, the Bluetooth technology emerged, which facilitated the short range communications. So we were able to connect uh, to the nearby devices, like we were able to connect our headsets to our phones, or we were able to connect phone to phone when we were near. So in 1999, this Bluetooth technology emerged. And in the early 2000s, this 2G cellular technology emerged, and uh, the data transfer rates of this uh, were increased. Like it were able to give the faster communication, like 2.5 and the 2.75 generations of network. Uh, The GPS emerged into like GPRS, and yeah, so and this also enabled the web features in the earlier smartphones in the early 2000s. And after this, the 3G technology emerged. So this set the major leap in the mobile communication actually. So also this 3G technology offered the broadband for the first time in the history. So this enabled the video call feature, though the communication latency is high, but this 3G technology enabled the multimedia channel, so internet multimedia channel, which enabled video sharing, video calls, live streaming, etc. And it also had higher speeds than uh, 2G technology. And also we had a series of updation in the Wi-Fi protocol like 802.11a b g. Also the 5 gigahertz band was introduced, so to reduce the interference of the other networks. So that's how it evolved. So these are the internet protocols that are being used now. And this graph shows various protocols over range. So based on our specific application and the range our application is communicating, we can choose the protocols. So here the LAN, Wi-Fi, and the Bluetooth, Zigbee, these facilitates a small range. So whenever our devices need to communicate over smaller ranges, we can put these protocols as our first choice. Move to the next. So now let's go through the short range protocols that we have. So So these are some of the short range protocols. We have the Bluetooth, the early Bluetooth protocol, and BLE, Bluetooth Low Energy. So whatever the Bluetooth devices we are using now, let it be the AirPods or the Bluetooth speakers, they all have this Bluetooth Low Energy protocols. The main reason is we require the better battery backup in our the connectivity devices, audio devices like the AirPods and all. So this Bluetooth Low Energy ensures that it gives the longer time period battery backups by ensuring low power consumptions, and also it is able to connect only for shorter ranges. So so this Bluetooth Classic ensures the higher data rates. It is mainly useful for audio and file transfers, but this relatively uses higher power. So, and to overcome this, the BLE technology introduced. So this is specifically designed for the low energy, and the small packets are sent. Also, there is something called event-based reporting. So only the required informations are sent in this protocol. So the channel is reduced. So the channel rate is just 40 in BLE, while the Bluetooth Classic uses around some 79 to 80 channels. Also, this BLE uses small packets, so this is great for wearables like smartwatches or the smart rings or the battery powered sensors. So we can use this BLE for the short range and battery powered sensors and wearables. Yeah, and we have the mid-range protocols like Wi-Fi. Like if we are setting up the indoor systems like smart home systems or some health monitoring systems, we can use this Wi-Fi protocol, which provides low latency, uh, and it supports widespread hardware and widespread ecosystem. Also, it works well inside homes or small buildings. So it also supports various multimedia like video and free frequent data upload. Also, we have better security in the Wi-Fi. It also supports live streaming. So in the health monitoring systems, we can just get the live data with low latency. But the only drawback of this Wi-Fi system is it requires continuous power supply, where the power consumption is too high. Sometimes it can kill the simple sensors. So over the time, when the sensor gets continuous power supply, it will degrade fastly. So this is one of the disadvantages. Um, yeah. Also, it is very prone to obstacles. So this is one of the drawbacks of this Wi-Fi technology. But it is suitable for present smart home or present smart health monitoring systems. And we have Zigbee, and it is again one of the popular mid-range wireless protocol. So it supports mesh networking. Also, it supports the decentralized architecture. And you can see in most of the modern IoT powered system, Zigbee is used as the priority over the Wi-Fi network, because the data rates are much low, and they also ensures the better battery backup and lower power consumptions. So this mesh networking, right, it helps uh, to extend the coverage of the entire system. So whenever we need, and if you are speaking about the scalability of the entire system, this Zigbee ensures the scalability is done seamlessly because of its decentralized architecture, and also it supports the mesh networking, right? So the scalability is quite easy compared to the Wi-Fi protocol. But there is one of the drawback in this Zigbee, because of its less data consumption. In sometimes we can face some less data penetration in devices. So yeah, that is one of the main drawback of this Zigbee protocol. And we have the long range protocols. So LoRa and LoRaWAN, these are one of the advanced protocols that are being used at present. So now when we speak about scalability, if we speak about smart home systems, so it is going to operate inside some specified range. Even if we scale that, the range won't raise significantly, right? If you're just connecting our sensors inside our home in around 100 meters, even if we scale that, we will be extending the connectivity range to some 200 to 300 meters, right? So for that, mid-range protocols uh, you know give a better support. But what if we speak about industries, right? In the industrial revolution 5.0, we are just shifting our machines or shifting our device towards a wide range connectivity. Let's say if we speak about smart farming or similar to it, so it should connect over a wide range, right? Wide range of space. So there we should use these long range protocols. So this LoRa and LoRa WAN is very energy efficient with low data rate, and it ensures the long range communication. So these are ideal for the sensors that are distributed around or over the wide areas. For example, environmental monitoring, the smart agriculture, the smart industries, etc. Yeah, and these can cover sensors ranging over kilometers. So but the thing is, they would only able to connect with the sensors when they are placed in less obstructed terrain, which means they just can placed in the smooth terrains, not the rough ones like the mountains, the valleys, etc. We can see the agricultural land will be mostly of the plain terrain without any much obstacles. So these protocols, these long range LoRa and LoRaWAN supports better for smart farming. Also, we have cellular IoT options for the adverse conditioned terrains. Like we have NB-IoT and LTE. So these use existing cellular infrastructure. So the advantages of these cellular IoT technologies are they support wide coverage, reliability, and they also ensures and give support for mobility. But the major disadvantage is they use more cost. If it is implied in the industry, they can afford. But if we are using it for personalized smart farming and other personalized uses, this should be a costly option for us. So yeah, there are also some Wi-Fi technologies which are emerging now, like Wi-Fi Halo. So, and the protocol of it is 802.11 AH. So, but it is still under testing phase. They are less mature. So, we are just cannot directly use it now for the real world scenarios. Yes. Any questions till this? Or are we good to continue?
Okay, madam.
Okay, thank you. Thank you, sir. So actually, this is a big slide. I just collated all the points we have discussed now, and I just compared how these short range, mid range, and the long range networks contradict each other, and this is more of the comparative analysis and trade-off. Maybe you can just go through when you receive this back, because we discussed this already. It's just a comparison. Okay. And moving to the next one, let's just discuss around some of the real world and practical use cases where we are just using these protocols in our day-to-day life. The first thing is the wearable and smart health systems. So here, Bluetooth Low Energy is often selected because of its low power and periodic small data transfers. Even in our wearables, we would not require the continuous data transmission, right? Only when we request, we will receive the data. So in such scenarios, Bluetooth Low Energy is considered, like heart rate, step count. So only if we request those things, the wearables will give the data. uh, so in such scenarios, we can just choose Bluetooth Low Energy. Okay, only when we need it just bursts the data. In most of the time it will be in snooze mode. That ensures the power backup also. And for home automation, so already we discussed the home automation or the short range or the mid range IoT systems mostly use this Zigbee or sometimes BLE. So this Zigbee's mesh helps covering all the rooms. Also, it is it works under low power for battery lamps or light sensors. And if we speak about the monitoring aspect inside the home automation, Wi-Fi will be useful for the monitoring cameras or other sensors. And smart building or industrial IoT. Now, when we speak about this, the covering range will be quite larger than the home automation or the smart homes. Yeah. So here we can use some advanced Wi-Fi technologies, sometimes the proprietary mesh modules for the wireless sensors and actuators. Mm, for the wide floors and multi-story coverages, mesh topologies will help us to build, efficient wireless networks. And we have this smart agriculture and the environmental sensing, where again the range in turn becoming wider and wider. So here we would surely require the long range and low power things, because we in the smart agriculture we cannot ensure the continuous electricity every time, right? So here the power consumption also the main thing. So we should choose our protocol based on that. Yeah, and we have the mobile devices. So when we transfer the device from geography to geography, we also ensure that we are choosing the good protocol. For example, tracking, vehicle monitoring. So for that we can use the protocols like LTE, NB-IoT, and other cellular protocols that supports various geographies and topologies. Yeah. And moving into the next. So now let's just deep dive into the next thing, the MRUB. Okay. So what is the scope again? So we all already know MRUB is nothing but it is the lightweight implementation of Ruby programming language. As we already discussed, these all the internet protocol should use a low power consumption. It should be lightly handling, etc. So now these mruby facilitates that. Okay, as it is already lightweight protocol or the lightweight framework implemented on ruby programming languages, so we can use this mruby for certain aspects, while we cannot entirely replace the C or C++ in the existing IoT system with the mruby, but we can try to incorporate this framework wherever and whenever needed in some sensors. So yeah, moving into that, let's see how what is the scope of mruby. Yeah, so the key characteristics of this mruby includes its lightweight and minimalistic approach, because it has a very small memory footprint, and it has the compact set of features. So when we speak about ruby language, it includes many libraries, you know wide range of libraries, where this mruby framework omits many libraries, and it just calls the necessary libraries when implemented in systems. So yeah, and also this mruby programming language is very easily embeddable uh, into other applications. For example, so we already discussed most of our existing IoT system, or the existing embedded system use C and C++ languages most of the times due to the availability of the vast libraries. So this mruby supports uh, the C and C++ wrappers. They can just directly call the C and C++ code snippets, and it will allow them to run in under its framework, under its environment. So this is one of the advantages. While we cannot directly use this mruby directly into our system, we can just call the existing C and C++ wrapper to run inside this mruby framework. So it is one of the main advantage of this when we use it in our systems, lightweight systems. uh, Also, see, mruby supports the byte code. So when it is compiled, so the code is converted into the byte level code. So instead of directly implementing mruby source code, this mruby framework includes a bytecode compiler, which we call as mrbc, and this compiler translates the high level, the heavy ruby code into compact bytecode format. So that can be executed by a small efficient virtual machine, like a small and lightweight microcontrollers. So this pre-compilation step reduces the overhead on the target device, and it doesn't need to parse the Ruby source code at runtime. So in the compiler time, it is just converting the entire thing into a bytecode. So as I already uh, said, so this mruby framework is designed to be highly portable, and it can run on a wide range of platforms, like Linux, Windows, Mac OS, and various other microcontrollers and embedded platforms. So yes. And going to the next, we have this so let's see now how this mruby fits into the wireless protocols. Mm, so we already saw in the previous slide. This mruby framework enables the developers to use you know Ruby language for applications that communicate over wireless protocols like LoRa, Wi-Fi, and it is used to interact with sensors and other devices. So, so most of the system primarily use this LoRa, LoRaWAN, and Wi-Fi technologies for wireless communications. So we have this Ruby framework that supports this too. So the first thing would be the lightweight nature of this. Uh, so it earlier it was limiting the resources was earlier only was possible, or it was only feasible in C language, but now we can implement this M Ruby framework to limit the devices and resources that is operating inside a wireless system. And hardware access, this is one of the main aspect again. So again, our mruby framework includes real time and hardware access functions, and it also allows the integration of C libraries via wrapper function. Already we have discussed about it. So it enables the control of hardware directly, which is the essential for wireless communication. So also our mruby, this framework is well suited for developing applications in the IoT, uh, where we'll be exchanging the data wirelessly. So yeah, so there are many researches that are going on, and already globally many researchers implemented mruby uh, of devices using LoRa and low power wireless protocols and all. So yeah, and we have certain frameworks like PAPMO that have enabled mruby programs to utilize TCP and IP protocol stacks. So because that is crucial for network communication, right? And also this mruby framework, right, it enables various network analysis tools like wireshark, etc., to create custom dissectors in ruby, so which helps to analyze various networking protocols. Moving into the next, so here I've listed various mruby gems that is useful for wireless protocols and that are readily available for our use in the ruby interpreter. So these are some of the hardware integration gems. So and we have many microcontrollers and microprocessors, in which ESP32 is one of the main microcontroller that we have, which supports a wide range of wireless protocols like Wi-Fi, Bluetooth technology, and it is more often used in IoT technology. And we have this gem mruby ESP32 I2C gem to implement the mruby program inside our IoT system. So GPIO gems are nothing nothing but they are the general input and output processing gems, which ensures that uh, the data is being input safely and it is again being transmitted to the you know the receiver system securely. So these gems controls that, and so we have other gems. Wait a minute. Yes. So these networking and communication gems, you know, these ensures the seamless wireless communication. So this mruby socket, this socket helps us to communicate between the devices securely. And yes, this mqtt, right, we have the specific gems that is curated for mqtt communication. And this mruby ping, this is used for pinging various devices that is connected over the internet. And we have this http gem that is exclusively for the communication over internet. So yes, these are the specific gems of the mruby. So any doubt till this? Okay, I think we can move to the next thing. So, how these gems are used or incorporated in the IoT and embedded systems. So, first thing is we as a developer should choose the necessary MRuby gems based on the hardware we are using and based on the network protocol we are just going to imply in our entire system. Like we should just list down requirements like I2C communication or the other network connectivity. And the compilation aspect, we have to consider this compilation aspect. So these mruby gems are compiled alongside the mruby interpreter and the application's mruby code. So this process integrates the C-based functionalities of the gems directly into the mruby executables. And when we come to the deployment side, so the the mruby is compact, right? So this the resulting compact mruby executable including the gems is then deployed into the memory constrained iot device and the power constrained iot device. So this approach, allows the mruby and the mruby gems to leverage the efficient C libraries for low level IoT application or the low level embedded hardware applications and the communication, while providing the wide range of developmental benefits, right? So yeah, these are the things. And yeah, we are almost to the end. So the platform is now open to the questions. Any
Participants,
questions?
have any queries?
So maybe next time, so when you design some project or when you tend to design some IoT system, you just can consider this mruby gems for experimenting for some low level systems, for low level IoT systems. For example, if you're planning to implement some environment monitoring system inside your college classroom or inside your college premises, you could try implementing this because the range will be too low, and this will allow you to experiment safely, and you can think of expanding this for higher level systems.
Okay, sure, ma'am.
Yeah.
On behalf of Price College, I would like to thank today's session, this session, Sharmila ma'am. Thank you,
Eh,
ma'am. Thank you for your wonderful, innovative interaction session. Thank you.
Yes, thank you. Thank you so much for the opportunity, sir. Yes. I'm just really glad that I had taken these sessions. Thank you.
Thank you.
Okay, if we don't have any queries, can I leave the meeting?
Yes, ma'am. Thank you.
Yes. Thank you. Thank you, sir.
Participants, please wait for a few minutes. The resource person will join. After you join, the session will start.
What is problem, ma'am? Madam, it is not audible.
So not yet start the session, sir. Wait, sir. Once the resource person will join, the session will start, sir.
Sir, next session time.
No, sir. Before 3:10, we will start, sir. Participants, please kindly stay in the TV room. The resource person will join within few minutes. Thank you for your patience. Please stay on the meet. Thank you. participants, thank you for your patience. Please stay connected. The resource person will join within few minutes. participants. Our resource person was joined. Welcome, sir.
Good afternoon, all. Good afternoon. Thanks for having me. Thanks for the invitation.
Good afternoon, sir.
Good afternoon.
Once, sir, now start, sir. Can start, sir.
Yeah, sure. I'm just sharing my slides.
Okay. Now, I welcome you, sir. On behalf of Christ College of Engineering and Technology, myself, Arun Kumar, Assistant Professor ECE, uh, I welcome you for Atal sponsored faculty development program. Today's second session, the topic of security and scalability in low power IoT systems. Now, I would like to invite our department colleague, Mrs. Susitra ma'am, to introduce our resource person in the session. I welcome you all. Thank you.
Good afternoon to all for this wonderful event. Myself Susitra, Assistant Professor in Christ College of Engineering and Technology. Now, I am going to read the profile about the resource person, Dr. Rahul Johari, Associate Professor, Department of Computer Science from University of Delhi. He pursued Masters at the Department of Information and Technology from Guru Gobind Singh Indraprastha University, Delhi, and completed his PhD in the Department of Computer Science from University of Delhi. Also, he has postdoctoral research in School of Computer and System Sciences from Jaipur National University. He is a Microsoft and Google certified professional and ODEM certified blockchain faculty. He has work experience of about 26 years. He has worked as a system engineer at Data Nova India Private Limited from July 1999 to July 2000. And then he has worked for Center for Development of Advanced Computing at Noida from September 2001 to September 2007. And from September 2007, he has started working for Guru Gobind Singh Indraprastha University, Delhi as an associate professor till date. His specialized domains are IoT, cybersecurity, cloud computing, blockchain technology, UAV, wireless network, and metaverse. He has been awarded with 7 patents and 6 research papers have been adjudged as Best Research Paper in Scopus Indexed International Conferences, and he has awarded with Outstanding Researcher Award at Guru Gobind Singh Indraprastha University for the academic year 2023 to 24, 2014 to 15, and 2013 to 14, and awarded Certificate of Appreciation from Honorable Vice Chancellor on Teachers' Day
No
on
problem,
September
ma'am.
5th, 2022. Now, I hand over this session to the resource person, Dr. Rahul Johari, to start the event about security and scalability in low power IoT systems. Thank you, sir.
Thanks for such a nice introduction.
Thank you, sir.
Is the voice audible to all? Please let me know if the voice is audible.
So, yes, sir, it's audible, sir.
Great. So I'm just going to share the slides so that and let me know once it is visible.
Yes, sir.
Is it visible now?
Yes, sir. Visible, sir.
Okay, great. So good afternoon, everyone, from my side also. As ma'am has rightly introduced, Myself, Rahul Johari, and I am working as an associate professor with Guru Gobind Singh Indraprastha University in Delhi. So, thanks for the invitation. Thanks to the organizers for inviting me to discuss about the very prominent topic that talks of the security and scalability in the low power IoT system. Now, before we proceed further, just a brief, this is about my university, IP University Delhi. And whatever I'm going to discuss in today's session, if you have any doubt regarding it, anything not clear, or if you want any, because I will cover in the code aspect also. If you have got any doubt in the code in the simulation, please you can ping me at my mobile number, or you can drop me a mail, rahul@ipu.ac.in, and I will be happy to take the queries on my mail ID or on my WhatsApp. Before I start with the session, in my university, I have set up a small lab called as a Swinger Lab. I will just share the, yeah, yeah. So it's called Swinger Lab, Security Wireless IoT Network Group of Engineering and Research Lab. Now, is this website visible? Anyone can say yes or no?
Yes, sir. Visible, sir.
Fine, fine, fine. Yeah. In
Yes, sir.
this lab, yeah, thank you so much. In this lab, what I normally do, I carry out a good work in the area of IoT, in the cloud computing domain, in the blockchain technology, cyber security, and very recently I started the work in metaverse that talks about augmented reality and virtual reality. That's a lab which I have set up in my own university. We also offer internship opportunity to the students, all free of cost. We don't charge anything from them. And whatever research publications I carry out here, and I've been fortunate, no doubt about that. By the blessings of God, I've been fortunate enough to work with many number of the students in my academic career, spanning across 2 decades. And most of my research publication has come not only with the PhD students, but also with my master's students as well as my undergrad students as such. So what best I could have is my have their own photographs and enrollment number along with me. So just a token of remembrance that yes, these are the students I have worked on in the last couple of years who in my lab, and we have been able to carry out some of the good innovative research. No doubt about that, because some of the students have been very energetic, very enthusiastic, and since this is a Gen Z, and they are full of energy, they've got a lot of creative ideas, and we work together, and we have been able to, just as ma'am rightly introduced, right now we have got more than 100 plus Scopus Index publication coming out of this lab. All credit goes to the students because I, as a mentor, is always there to supervise them. But ultimately, it's the energy of the youth and the experience of the faculty member like us, which can actually create the good atmosphere where everyone can prosper. Not only we evolve as a faculty member, but our students also rise a lot. Well, ultimately, they have come to make their career with us. So we have been able to achieve good number of publication in our lab and all in the happening field. IoT is definitely one of them. I've been working on the multiple tracks of the IoT, like the routing in IoT, congestion control in IoT. Rather, my own PhD was also in the domain of delay tolerant network. I did my PhD from Department of Computer Science, University of Delhi, under the guidance of Professor Nilima Gupta. So she is very dominant expert in the field of the networks. So I learned a lot from her, no doubt about that. We were able to get a good number of SCI publications in the field of delay tolerant network, which was happening field around 10 years back. Later on, not much work came into DTN, but primarily in India. You in US, so still NASA and many of the organization, the work is still going on in the field of DTN. But still then, all research publication were in the top 10 in India for the couple of years. Then I did my postdoc from Jawaharlal Nehru University again in Delhi under the supervision of Professor Deo Prakash Vidyarthi in the field of blockchain technology. So I can say I've been fortunate to work under the supervision of some good teachers. I learned a lot from her, not only academically, but also the nuances of research, how to carry out research, how to identify a problem statement, because we always say in research, finding a good problem is itself a problem, right? Because, and those of you who are in the early stages of your research, or those of you who have completed your PhD, or those of you who are looking for a topic for your students. So I will definitely say, in today's environment where so much number of the AI tools have already engulfed in our domain, we still need to find out the right solution for the right problem, because AI tools are there to help us out. They actually can't bring a solution to any problem. That's my forte. That's my perspective. Maybe the perspective can vary from person to person. So we need to be novel in our approach. We need to be innovative in our approach, because problems are plenty in whichever domain you are working. Like for example, in the IoT in this case, or we should take blockchain technology, cloud computing, cyber security. These are the areas in which I work. There are plenty of topics. There are plenty of issues which need still to be resolved, and these AI tools can be exploited by we academicians and researchers to find the good and innovative solutions, because solutions have to be come from our side. The tools are there to help us out, but they can't dominate. They can't tell us what to do and what not to do. That's a first level of a solution has to be proposed from our side. That's my take on it. So we have been able to do some good quality work in our lab. One of such work is definitely in the area of IoT. I will covering the simulation aspect in today's talk, how to do a secure routing in the IoT using the publisher subscriber model. So I will discuss in the code how to write the code in Java. And those of you who are interested, I will be happy to share the code. You can replicate the same thing on your machine and see the benefits of having a secure routing in the IoT. Yeah. Now, since this, I think it's the last day of the FDP, many academician and researcher would have already discussed about the various aspects of the IoT. So, just a recap of it. We all know credit goes to Kevin Ashton, a British technology pioneer who co-founded the Auto ID Center with MIT US, which created a global standard system for RFID and the other sensors. So, if at all the credit needs to be given to anybody who discovered IoT or who introduced the IoT, it's all the Kevin Ashton. And for his work, he was also uh, one of the nominated for the Turing Award. Um, because we all know in computer science, we do not have the Nobel Prize. The best award we give to the academician and researchers who do outstanding research work is the Turing Award by the ACM, Association of Computing Machinery. And as a teacher, I can say the considering the population of engineers which we churn out from the engineering colleges every year, we should have got more than maybe 10 plus awards, because ACM started giving the award in 1965. So right now it's 2025. So more than 50 years have gone by. So in 50 years, considering the population we have got in India and the number of computer science engineers which passed out, we should have got at least 10 plus award. But unfortunately, we have been able to get only one award. That too, again, the field of artificial intelligence by Professor Raj Reddy. So Kevin Ashton was also, and the year was 1994. So if you really want to inspire us to do something good, something great, do give them these kind of examples, because that's the inspiration they look forward to. That what to do good quality, how to achieve good quality research. So we need to inspire them with some good awards. And ACM Turing Award is definitely one of them. Prize money is handsome, quite luxurious prize money, and you get the name and fame. Recognition is exciting for the youngsters. And he never got the award, definitely Kevin Ashton, but he was nominated for the Turing Award. And all credit goes to him that in 1989, for the first time, he coined the term of the IoT, Internet of Things. Now, there are many people who tried to define the IoT in the last couple of years. There are multiple definitions also that exist of the IoT. So this I'm just sharing one of them. It's a collection of physical objects which can be movable, which can be immovable. It could be devices, the electronic devices, the Wi-Fi enabled devices, the smart devices, the vehicles, again a two-wheeler, a four-wheeler, a flying vehicle, a drone, a unmanned aerial vehicle, a autonomous vehicle, the gadgets and the other items which are embedded with the electronics, software, sensor, and very good connectivity, because that plays a very important role in the smooth functioning of any IoT system. Network connectivity has to be strong, robust, and reliable, and which helps to exchange data with one another. So IoT is all the collection of the objects, because that is what things stand for. A smart object, electronic devices, which are Wi-Fi enabled, which are network compliant. They follow almost all the global standards of the networking. And if you are able to carry out the exchange of information between such devices, then nothing better than that, because that is what the IoT was meant for by the Kevin Ashton. Are the slides moving? Anyone can say yes or no. Are we able to see the rotation of slides, navigation of slides? Uh, I hope so. And any problem you encounter, please, you can, if you can type in the chat window, or you can say, I'll be happy to answer it. So here we got a IoT device life cycle. Now, cycle is something that happens. Every device has to go through it, because this is in a normal cycle. If you deploy a device in the real time scenario, so every device has to go through multiple phases. And that is what we mean by the IoT device life cycle. So first and foremost, deploy any of the device. You need to deploy the IoT device in any real time environment. So maybe, for example, I have been given a task to measure atmospheric temperature, pressure, humidity, soil condition in the environment where, let's say, in the desert region of Rajasthan. And we know Rajasthan is one of the Indian states, very hot and humid for most part of the year. So that is one of the problem statement that is being given to me. So what I will do, I will buy sensors, I will buy the devices and deploy them in hundreds and thousands in real time scenario in the desert region of Rajasthan. Or maybe I have been given the task of measuring atmospheric temperature or pressure or humidity in, let's say, in the Uttarakhand region of the in the Himalayan region of the Uttarakhand state. Because those of you who might have gone to the Char Dham, four Dham, or four religious places like Badrinath, Kedarnath, Gangotri, and Yamunotri, they're all located in the Uttarakhand region. It's all very hilly region, mountainous region. The terrain is very vulnerable, uneven, imbalanced. And recently, we have got a problem with the cloud burst also happening in that region. As a result, huge flash floods came, engulfing many number of villages in its flow of the water. So deployment is very important. How do you deploy a device? Where to deploy the device? And how many numbers to deploy a particular device? That's very important. And once the deployment has been done, now comes the major task: monitor and servicing. We can think together, because you need to monitor the device on daily basis, almost 24 by 7 by 365. Is your device working fine? Is it able to capture the data in a real-time environment? Are there any wear and tear? Is a device vulnerable to natural calamities? So we all need to monitor it. And if some problem arises, then carry out the proper management and the service of that particular device. Maybe software upgrade, maybe hardware troubleshooting, maybe energy level issues, because today's talk also discuss about the security. Maybe your device has been hijacked by the hackers, and remotely they are monitoring and maneuvering your device. They are controlling your device, and you are believing that your device is very naive and simple, and is capturing a wrong data, because some hacker or some intruder is actually controlling the device. And whatever data it captures, it maliciously changes it. The values are fiddled. So servicing and management is a very important part of any IoT device. Then we require a proper updation, in the sense that once the device is properly serviced, managed, monitored, now you need to make sure that the device is properly updated with proper software, hardware, And if at all any real-time changes arises on the customer problem statement, you can accordingly update in the device that this is what I want, and now plus more information need to be captured by the IoT device. So I can do a periodic or regular updation in my device. Then once my entire experiment has got over, now it's a time I can go for decommissioning of the device. Now you destroy the device, or you do because device might get used by somebody else. So it's better to destroy the device in a most biodegradable manner without causing much disturbance to the natural environment. So what we call decommissioning of the devices in a most better manner, following the SDG goals, sustainable development goals, with a minimum threat or disturbance to the environment as such. So when we do the management and updation, we also need to worry about the security of the data. That if we need to protect the movement of the data between the devices so that it doesn't get captured by the intrusion. And accordingly, our system should be scalable. Means as and when there is a requirement, I can increase more number of devices, I can decrease more number of devices. That is called provisioning and deprovisioning. You can increase the capacity of your devices if required. So you can cut down the capacity of devices. So you are the administrator of the IoT network. It's your role, it's your responsibility, not only to manage and monitor the network, but also to make sure that your devices are foolproof. They don't get into the hands of the intruders or the hacker, and they should be scalable enough to meet the customer requirement. So if the customer requirement is dynamic, it scales up, it scales down as per the need. So should be your system. So it should match to the real time changes. What the more the problem statement changes, the customer requirement changes, you should be able to immediately tune up or tune down your system. That is what the and plus your and IoT device should be very energy efficient, because if they consume a lot of amount of energy in their transmission of the data, sharing of data, then nobody would like to buy your device because it's consuming a lot of energy cycle, the CPU cycles, fetch, decode, execute, and the write back cycle. So we need to work on the energy preservation also of the devices, energy conservation, so that your devices consume less amount of data when they are actually deployed on the land, because they are in the hands of nature. So if they consume a lot of energy for every operation, then nobody would like to buy the device. So that's another problem we have to make sure that we cater to when we actually deal with the deployment of the device in real-time scenario. So that IoT device lifecycle, though may look like just having 4 to 5 steps, but all these steps are very crucial and critical in the management and the monitoring of the device, and they need to be done in a very good manner by the proficient expert, the domain expert, so that your system works seamlessly and smoothly without any problem. Yeah, and once you're done, you decommission the device. Now, today IoT is everywhere. You go to any place, you exploit any domain, everywhere you will find the IoT's application. You can find it in your own home, like nowadays we have got a smart refrigerator, smart television, smartphones. So now we can easily have the communication between the refrigerator, television, all with the help of the sensor. They all can recognize each other, and if you require to communicate, you can always send the message. For example, I am just sitting on the couch of my sofa set on my room, and there is a bottle in the water bottle. There is a water bottle that need to be refilled in the refrigerator. And so the sensor deployed in the refrigerator should check the level of water within the water bottle. And if it falls below the threshold value, immediately the sensor of the refrigerator should communicate with the other sensors of my home, and these sensors will track where am I. I may be lying on a bed, or I may be watching a smart TV. I may be watching a football match. Tomorrow there's a cricket match between India and Pakistan. So majority of the Indians and Pakistani around the world will be glued to that match. So the sensor on my smart TV should immediately replay a message, because they have tracked me up that I'm within the range, 10 to 15-meter range of the smart devices, and immediately the message should get flashed. That's a time to refill the water bottle. So that means me as an object will be immediately alerted by my smart TV because my smart refrigerator is now communicating with the smart TV and telling me that what need to be done. Similarly, there are maybe certain rotten vegetables lying in my refrigerator. So again, the sensor can keep on checking the freshness level of the vegetables in the refrigerator. So if they find that the vegetables are not so fresh, they are stale, they are rotten, immediately it can be informed to me wherever in my living room, my bedroom, my drawing room, my study room, that there is a problem in the vegetables kept in the refrigerator, and now it's a time to either use them if they are still fresh, or maybe time to throw them out in the garbage if they're totally rotten or they have now become useless. So nowadays we have got a smart TV, smart homes are there, where I can keep, where my devices are getting smarter, much more intelligent, all with the help of sensors, so that they can help me out in my day-to-day activities. Another prominent example which are being now used, automatic switching of the ACs, the lights and fan when no one is in the room. Because to preserve energy, to preserve electricity, again, our smart bulbs, smart tube lights, smart fans, remote controlled fans, everything is there which can actually help to preserve the energy. When I'm, for example, when I'm not living in my home, I left for the office, all the lights, all the fans should automatically get come into the off state, should get tuned off, because why, to waste the energy as such. So automatic switching of the ACs, the lights, and even if I forget them to switch off the devices, then should be smart enough to detect the presence of any object in a room. If no object is there, no human being is detected, immediately they should go into the off state. Then today's nowadays sensors also being used in the walking stick for the blind people. That's another prominent area which is getting a lot of attention. Now, what happens in these areas is that there are people with disabilities. There are many number of disabilities, more than 15 of them. And nowadays we are getting a smart specs, smart sticks, smart helmets, smart shoes, smart belts, which can actually be used by these people with disabilities, especially the people with visually challenged abilities. They can be used by them to navigate on the city roads. So audio applications are getting plenty. Another prominent example would be refilling of the petrol in the car or the airs in the tires. Normally, when we drive the car, we don't get an alert when the air in our tires of the car is very low. So we should also get a sensors fitted along with the tires, which can help me to tell that yes, the air in the tires of the car are below the threshold value and they need to be get refilled. They need to get again the air need to be filled in them. So again, I can have the sensor deployed with them. We can have the automatic watering in the fields, meaning sensors switch on and off of the water sprinkler as and when the soil turn dry. So there could be many applications which can be used in today's environment of the IoT ecosystem, which can make the life of a person in a society very easy, very comfortable, because that is what the devices are meant for. That is why the system is designed. And we need to make sure that the systems are scalable in nature. Means according to the human requirement, according to the customer requirement, according to the problem statement, you can increase them, you can decrease them, you can change their power, you can change their capacity, and you should be the boss of those IoT ecosystem. And the system should tune up or tuned out as per your need, as per your requirement. So that is most important, to design the scalable system which can be actually be tuned. Dynamic tuning is required in the systems. Now, some of the key technologies which we see that works along with the IoT into the environment, like I can use in the big data tool like MongoDB and Hadoop, because once the sensor captures the data, there are humongous amount of data. So I need to have the big data technology, because the data can be structured, data can be unstructured, data can be semi-structured. So I need to make sure that proper tools are used to manage the data which has been captured by the IoT devices. Also, I can blend or I can integrate IoT ecosystem with a cloud computing, because we normally talk of the sharing or the relaying or the distribution of data among the multiple nodes, clusters, or server. Now, this is where the MICEF computing, MICEF, MIST, IoT, cloud, Dew, edge, and fog computing, they all work hand in hand on a common platter. So IoT today cannot work all alone. It's very difficult to design a system that works in isolation. You have to integrate with the other existing technologies. So they need to coexist, they need to cohabitate with other technologies in today's environment before taking any smart decisions. Then security of data is an important task. We need to make sure that the data captured by the devices are safe, secure, and reliable. That is what we say SRS, safe, reliable, and secure. And for that, we can adopt cryptographic techniques. Now, cryptography, since most of you are faculty members or maybe the research scholars pursuing the PhD, we know cryptography is divided into two categories, symmetric and asymmetric. Symmetric are the ones that uses the single key, both for carrying out encryption and decryption. And asymmetric cryptography is one that uses a pair of keys, one public key and one private key for carrying out encryption and decryption. So today there are a large number of cryptographic techniques like Caesar cipher, Veneer cipher, Railfen cipher, affine cipher, hill climbing cipher, and many other cipher techniques. There are plenty of them. We also have algorithms, both symmetric and asymmetric, like data encryption standard DES, advanced encryption standard AES in the symmetric cryptographic category, or we have got a RSA algorithm, Rivest, Shamir, and Edelman algorithm in the asymmetric cryptograph category. Are we able to? I hope we are able to connect, and able to share the viewpoint with you. The cryptography is very, very important to ensure the security and reliability of the data. Nowadays, beside cryptography, we also use the hashing. We also use the blockchain technology because the core of the blockchain technology is all hashing. Now, what do we do there? We use the hashing algorithms like MD5, Message Digest 5 algorithm. We use SH algorithm, secure hash algorithm. So these algorithms play a very important role in ensuring that the integrity of the data doesn't not get violated. Because when you talk of the cryptography, we have got three fundamental principles: confidentiality of the data, integrity of the data, and the availability of data. So cryptography handles the confidentiality of data, whereas hashing or the blockchain technology works on the integrity of the data. That the if at all the bits in the data get corrupted or violated, then hashing will be able to immediately tell you. And that is why hashing algorithms are different from the cryptographic algorithms. So both of them are very closely related to each other, cryptography as well as the blockchain technology. But they're not same, not at all. Their roots are same, the technologies are different. Their objective is same to ensure that is security of data. But how do they do it? That is different. Their strategy, their approach is different because cryptography works only on confidentiality, on ensuring the confidentiality of data. But the blockchain works on the ensuring the integrity of the data. So we need to be very clear that we are working on which aspect of the security of data. Then a lot of work is being done in the data analytics part today. So we can write in our own algorithm to analyze the captured data to take some logical decision. Or we can use predefined supervised and non-supervised learning algorithms like naive Bayes, support vector machine clustering, reinforcement learning, deep learning, and nowadays you got generative AI. So these entire AI platform can be integrated with the ecosystem, IoT ecosystem, to make a smart decision, to make a smart prediction of the IoT devices. And we can also work on the security of data with this AI. Because AI can be used, if I'm working on security of data, we need to have a knowledge of attacks because many number of intruders and hackers around the world launch the attack on the data in the IoT ecosystem. So there are multiple types of the attack, like birthday attack, replay attack, denial of service attack, distributed denial of service attack, collaborative attack, birthday attack. Many number of attacks are there as such. So I need to make sure that my data remains protected against these kind of the attack. So if I'm working only on the attack philosophy, so again I need to decide that whether I'm working to using AI to plan an attack or prediction of an attack or prevention of an attack. So again, I need to identify my research objective in the IoT ecosystem when I'm working on security of data. So I repeat my statement again. I need to identify the track which actually excite me, which is of interesting aspect to me. I can work on making a planning an attack. I can launch new and innovative attack in this category, something which has not been known in the past. I'm able to do it for the very first time. Or I can work on the prediction of attack, that uh, what all attack can happen in the coming days or coming months, analyzing the current situation. Or I say that I'm able to detect an attack, and therefore I will be able to prevent an attack, because you need to have a knowledge of the attack first. Then only you can devise the strategies to make sure that the detection or prevention of the attack actually works. So I can use the AI to handle multiple tracks when I work on the security of the data in the IoT ecosystem. So the point in this slide I'm trying to convey is that there are multiple technologies which can be blended, or which with the IoT can be integrated to make it much more meaningful for the not only for the audience, not only for the researcher, but actually for the client, the customer, for which we are actually solving his problem. Now, IoT ecosystem, the devices can be deployed either in a controlled environment like a lab, or in my known location, my office, my university, or it can be hostile. For example, deployment of the IoT nodes in a desert region, or in a ocean sea beds, or maybe in the mountainous region, because they're all open domain. Can be again vulnerability can actually arise. So I need to have a sensors, because we know IoT is all a game of sensors. You need to have the good sensor, a right sensor, because when you go and buy a sensor in the market, there are sensors for multiple number of applications. For example, sensor for monitoring and measuring atmospheric temperature, pressure, humidity, seismic vibrations for prediction of the earthquake, for measurement of the soil condition, and so on and so forth. There are multiple number of sensors which are all being designed and developed in today's environment. Now, most of the devices today we know are made in the China or Korea, or North Korea, South Korea, Mongolia, Taiwan, because that's a real hardware hub of the world. Majority of the electronic components, the semiconductor devices, are all being designed, developed, fabricated in these countries only. So all the almost most of the sensor come from this country only. So, and you need to be very specific that what kind of sensor you're looking forward to. So if whenever you're given an IoT project, or if you're handling an IoT project, you must be very clear that what your purpose is, what is your meaning, what is your vision and mission for your particular project. Because that should be very clear in your mind, so that accordingly you can buy a right sensor from the right vendor. Because today there are multiple number of sensors, like hundreds and thousands of sensors, which have actually engulfed the market. So hundreds and thousands of sensors are available today. For example, I can have a sensor for color sensor, a gas sensor, a smoke sensor, alcohol sensor, PIR sensor, rain sensor, IR sensor, touch sensor, gyroscope, soil moisture sensor, ultrasonic sensor, thermistor, air receiver, proximity sensor. There are so many number of the sensor. Sensor for every reason, sensor for every season. These are only few of them which I could actually find on the web, but there are many more of them. They need to be very careful that what my objective of the experiment is, because most of the sensors are unicasting. They're not multitasking. A single sensor will not be able to do more than two or four or six objectives at a time. Sensors are um, purpose oriented. They are designed for specific tasks. So I need to buy the right sensor from the right vendor and for the right device. Otherwise, the sensor will not be able to they will not be able to capture the correct data, and then I have a problem. Now, if you go to buy a sensor in the market, there are many number of companies in Delhi which actually sell sensor today, and there is a good companies also in Bangalore which sell the sensor. So across India, you will find many number of vendors. Now, for example, if I want to purchase a sensor like say smoke sensor, or the alcohol sensor, or the water flow sensor, or the IR receiver sensor, the sensors are available in the market in the range of 250 rupees to 2,500 rupees, and some sensor cost even 25,000 rupees. So, what differentiates the sensor? Precision, quality, accuracy, configuration, weight, multiple number of things. The vendor, reliability and credibility. For example, there's a sensor from Texas Instrument in Bangalore, what you call TI. They are considered good quality sensor because once you write a research paper and you want to get it published in the SCI or the ESCI journal, so your quality has to be good, your reliability of the has to be good of the work you do, and you need to specify the what kind of sensor you have used to actually carry out your research work in the labs. So if you say that I have been able to carry out the research maybe on security aspect, on a power driven, on energy aspect, or the scalability aspect, on any of the aspect, using the sensor from Texas Instrument Bangalore or from any other good quality vendor, then definitely the reviewer of the research will be impressed. He or she will say, okay, that you are a good, smart researcher and you have purchased the right sensor from the right vendor, from the right people at the right time. And your results will not be doubted upon. It will believe that your research quality is good and your results which you generate and the plots you do, the histogram, the bar chart, the pie graphs, all of them are good. And then you can, and anyone and everyone can rely on your result. The so analysis part of the result is good because you have been using a good quality sensors. So selection of a sensors, purchasing the sensor is very important part in the entire IoT ecosystem because you should not purchase a low quality sensor which will give you the bad or the flawed result. And the result has to be right, and for that the data input has to be correct. Data need to be captured at the right place at the right time from the right vendor. If it is not, then you can always doubt the integrity of the data. You are not sure that the result which you are getting is correct and you can actually rely upon. Difficult, very difficult as such. So, selection of a sensor in a project, identification of the problem statement, and delivering a good quality result, I think, is a major fundamental stone for the successful execution of any project that deals with the IoT ecosystem. Now, if I'm a researcher working in the IoT, I should be very clear that in which domain I'm working on. That means the problem statement, the research objective has to be very clear in my mind when I'm working on the IoT part. So there are multiple parameters, multiple issues that coexist together in the IoT ecosystem. I've jotted few of them for you, like what is the weight of the device? What is the amount of the internal storage, the gigabytes? How much internal storage the device has? Is the device scalable? Are the systems scalable? Can they be tuned up and tuned down? Can they be made uh, provisioning and resource provisioning can be done because that is very important aspect of the scalability. What is the rate of processing of the CPU? CPU processing power is what another input is required when I'm working exclusively in the IoT ecosystem. What is the CPU cycle in MIPS, million instruction per second? What is the state of security of the data? Are my devices secure? Are because I can employ the security at the both the software end and the hardware end. At the hardware end, though there will be a bit of level of security in terms of physical security, but it will not be able to give me secure reliability or because it is why it is not able to give because problem exists at the multiple level in the IoT ecosystem. So when I'm working on security, I need to make sure the device is secure both at the software level as well as at the hardware level. Like cryptography and blockchain technology I just discussed, they are the technologies that work on the software level of security of the data, right? Then another important task, very important task, is the energy efficiency. Because if I deploy an application, I need to make sure that it consumes very less quantity or very less number of CPU cycles. If it consumes more number of CPU cycles, then nobody would like to buy my IoT device. So I need to make sure if I'm a hardware vendor, if I'm the OEM original equipment manufacturer of these devices, I need to make sure that my devices are energy efficient and they consume less number of CPU cycles. Because if my application is deployed, let's say secure routing application is deployed on the IoT devices, and during its execution, it's consumed a lot many number of CPU cycle, nobody will like to buy it. So my application has to be very energy preservation, energy conservation, and they should consume very less number of the CPU cycles. That is why only I can say my applications are very energy efficient, right? Then what is the mobility pattern of the nodes? If it's highly mobile, less mobile, or a semi-mobile as such. So if it is highly mobile, again, I need to check on the devices that are they static when they're deployed in a real-time scenario or they're moving. For example, the autonomous vehicles, the what we call driverless cars, or the unmanned aerial vehicle, the drones. Are my sensors or my IoT system is being used in those kind of a devices? I need to track the mobility pattern also. Then what about the routing of a data in an IoT ecosystem? If too much amount of data is crisscrossing or flowing between the IoT devices in a system, it might lead to congestion. And we need to have the congestion control algorithms to manage or mitigate the flow of the data. Or I need to have a efficient routing techniques, routing algorithms, which can actually do they can't do the decongestion, but they will help me to find the alternate path from where the data can be routed through to reach from the source to the destination. Then the routing. Now again, routing is a very important aspect. How do you move your data packets from source to destination? We need to find out or we need to determine the most optimized routing path which can be used to move the data packet from the source to the destination. Now, those of you who are working in the network, you would be knowing that when we talk of the wired network, IEEE 802.3 network, we use the routing protocol like RIP, Routing Information Protocol, or the OSPF, Open Shortest Path First Protocol, or the BGP protocol, Border Gateway Protocol. But if I go to the wireless network, what we call IEEE 802.11 standard, to 802.16 standard, there are multiple number of wireless network protocol, uh, broadly classified into static and dynamic routing protocol. Like we have got DSDV, DSR, destination sequence distance vector routing protocol, DSR, dynamic source routing protocol. So again, I need to identify which is the most optimized routing protocol which I can use for routing of the packets in the wireless network. Or I can have AODV, ad hoc on-demand distance vector routing protocol. But when we move towards the IoT has got its own set of the protocol. It does not uses the protocol of the wired network like RIP, OSP, PF, or BGP. It does not use the protocol of wireless network or wireless LAN like IEEE 802.11 standard, what we call DSDV, DSR, AODV. It uses own routing protocol like we have a low PAN network, 6LoWPAN, or it has got the MQTT protocol, message queuing telemetry transfer protocol, or it can be COAP, COP, called COAP, Constraint Application Protocol. So routing protocol in IoT are different from the routing protocols of the wired network or the wireless network. And that is what I'm trying to say. The routing is again important, very track in this entire topic. I'll also discussing some of the routing. I will showcasing the simulation if you are interested how to do efficient routing using the MQTT protocol in the IoT ecosystem. Then sensor we already discussed in the last slide, where it is a very important part in the IoT. Selection of sensors, procurement of sensors is a very important task because you need to measure the quality, the reliability, and the accuracy of the data being captured by these sensors. So it's very important task that you select the right sensors for the right problem statement. Now, when we talk of the security issues in low power IoT system, there are some of the things which we need to be very focused on, like weak authentication. So authentication is strong, robust, and reliable. Weak authentication is just not acceptable in the IoT ecosystem. So whenever you get any request to capture the data, monitor the data, manage the data in IoT ecosystem, make sure that the authentication is strong. Either you use the strong cryptography like AES or the RSA, Advanced Encryption Standard, or the RSA, the Reverse Chimera Delvin algorithm, or I use a blockchain technology, for example, MD5 or SHA algorithm. So authentication is a very important task when we talk of the security and the reliability of the data. That the firmware and the software exploit that need to be managed and monitored in a proper manner. Otherwise, that can create another set of problem. Data confidentiality and privacy, very, very important because I need to use the cryptography, like the symmetric cryptography or the asymmetric cryptography, to ensure that the data remains strong, protected, and doesn't land into the hand of adversaries, like oppositions, because they can play havoc with the data, they can manage the data, they can manipulate the data. So I need to make sure that my data remains strong, and it does not get into the hands of the enemies. Then botnet and DDoS, again, very important and powerful thing. I need to make sure that my data remain protected from the denial of service and the distributed denial of service attacks. Now, let's talk about the any doubt, any query till now. If you got any doubt, we're happy to take the queries. Anything not clear, whatever we discussed till now. Okay. So this session talks about the security and scalability, the two important aspects of the IoT ecosystem. So I will be sharing the protocol names, a brief description of them before we come to the simulation to see how I can actually simulate in a real-time scenario. So secure and scalable routing in the IoT. Now, if you look at this slide, it talks of the communication in the smart systems. Almost you can see the entire home getting engulfed with so many number of the devices: smart TV, smart refrigerator, smart ovens, smart microwaves, smart bins, smart keys, everything, smart doors, smart locks, smart fan, smart tube light, smart AC, all of them can now communicate with each other without any problem as such. So now only we humans are getting dumped, whereas we are making them smart devices. So there's a very good statement, if you can see here, internet of ransomware things. Now, security is a very important part because all these devices are now communicating with each other. So you as an intruder or a malicious hacker can actually intrude the network and disturb the flow of the data, disturb the accuracy of the data. So we need to make sure that the data remains strong, reliable, accurate, authentic, and it is not fiddled or manipulated by the hackers or the adversaries or the attackers or the intruders. So we need to protect the data when all these devices are communicating with each other. Now, how will these devices communicate? One of them is using a low PAN network, what we call 6 low PAN, stand for IPv6 over low power wireless personal area network. Now, that's a very important protocol, and today now it is being used across many number of the devices. One of the very good protocol. It's a communication protocol designed to enable small, low power devices to connect over the wireless network, because that is what our ultimate objective is. How to design, how to come up with the protocol that can actually cater to the requirement of the small, low power devices over the wireless network. So 6 low pan is one of the good handy protocol when we talk such a kind of the requirement of the IoT ecosystem. Other prominent protocol like MQTT, message queue telemetry transport, which I will just discuss now, and the COAP protocol, constraint application protocol, because these are the protocol exclusively designed to handle the issues related to the IoT ecosystem. So rather than using the protocol for the wired network, like RIP, OSPF, or BGP, or of the wireless network, like DSDV, DSR, or AODV, we should primarily focus on the routing protocol designed exclusively for the IoT ecosystem. That is 6LoWPAN or the MQTT message queuing telemetry transport or the COAP constant application protocol. So point is that once I start my IoT project, it should be clear in my mind what my agenda is, what my focus is, what I'm trying to solve, so that I can use the right routing protocol at the right time. Now let's discuss another very important protocol which is used for security and reliability. It's called as MQTT, Message Queuing Telemetry Transport Protocol. First invented by Dr. Andy Stanford of the IBM and Erlen Nipper of the ARCOM, which is now Eurotech, since 1999. Now, since their discovery, they also were nominated for the ACM Turing Award. So, if you also do something good for the or the Nobel for the very first time, then yes, it's worth of appreciation. If you have done something for the very first time, definitely it can be identified, can be patented, and because yours is a novel work, and just like the Kevin Armstrong, they were also nominated for the ASM Turing Award, but ultimately they also could not get it. They just remained as one of the nominees for this Turing Award. So you need to identify that what your problem statement is and how do you want to solve this problem statement. So you can use the right protocol at the right time. Now let's start with the protocol functioning to understand how does the MQTT protocol work. So MQTT is all publish subscribe model driven. So you'll have a publisher, you will have a subscriber who will communicate with each other, and the routing of the data will all happen through the MQTT protocol. So first remember that comes is publisher subscriber model of the IoT protocol. Extremely simple, lightweight, and the messaging protocol. So it does not take much of the time that will take CPU cycle, it will drain it off. No need, not at all required. You can just focus on the efficient routing because it's all simple, lightweight messaging protocol. It is designed, now that's very important aspect. This is designed for low constraint devices operating in a low bandwidth, high latency, or unreliable network. So even if your networks are unreliable, reliability is very low, delay is widely acceptable there, then also I can use the MQTT protocol because it's primarily meant for constant devices operating in a low bandwidth, high latency, or high delay oriented or unreliable networks. Now, let's look at the technical aspect of the MQTT protocol. It has a client server model approach. That means you will have a one client, uh, you will have another client server, and both of them will communicate with each other. And that is how we use the publisher subscriber model of the MQTT because MQTT uses the client server model approach to do the efficient routing between the publisher and subscriber. I will just share the diagram of it for the convenience of all the members, where every sensor is a client and connect to a server known as a broker over the TCP protocol. MQTT is a message-oriented protocol, so all the information flow in terms of messages, and every message is a discrete chunk of data, which is opaque to the broker. So all data transmission is done in the form of the messages using the MQTT protocol. Every message published to an address known as a topic. So you publish the message to a specific address, and that will be known as a topic. And clients may subscribe to one topic or many number of the topic. I will just share the diagram so they can better understand. And every client subscribed to a topic receives every message published to the topic. So publisher will publish the message for that topic. Publisher will publish the message for the topic, and the subscriber will receive the information about the same topic without any problem. Now let's look at the architecture. For example, imagine a simple network with, let's say, two clients. Client will be called as subscriber here, and one server, which will be called as a publisher here. So you will have two clients, a subscriber, and one server called as a publisher, and a very prominent central broker. A broker will maintain a list of the topic to which you want to connect to, right? And the client opens the MQTT connections with the broker. For example, client B and C subscribe to the topic. I will just share the diagram so you can understand it, that what are the clients where they are connected to. So clients B and C will subscribe to the topic. For example, if you see this, let's me show the data. Now here, let's see the example. We have got a broker in between. You have got a client A, client B, and client C. So broker plays a mediatory role among the management of multiple number of clients. And this client A and B and C are the IoT devices. So client A, we call it as a server or a publisher. So you can see the direction of an arrow. And client B and C are the clients, the subscriber. So publisher here captures the data from the real-time environment and publishes onto the broker. Whereas client B and C are the subscriber which subscribe to the broker. So publisher will publish the data onto the broker and the subscriber will receive the notification about those messages from the broker. So subscribe temperature. That's how it will actually work like. So client A will be a publisher, B and C are all the subscriber, which are actually connected to that particular broker to ensure that yes, the data remains strong, robust, reliable, and accurate. So proper communication is required or between the publisher and the subscriber. I hope the things might be clear. Now, before we start with the simulation, we also need to know about something called the quality of service level because in security and reliability, QoS parameter holds very significance. Now, there are three levels of security being provided by the MQTT protocol. First is a zero level, that is fire and forget. Do not worry about the security. No care attitude. I am damn worrying about the security. You just fire the message and then you forget that whether message has been delivered to the destination or not. Something what like the UDP protocol of computer network work, unreliable datagram protocol or the user datagram protocol, where you're not worried that whether the message will actually be delivered to the destination or not. You just fire the message and then you said relax, and you are sure that the data might be able to receive without any problem. But if I want that the packet should be received uh, with a destination and I want a proper acknowledgement, I can use a TCP protocol, like something what we do in the computer network. So in that case, I need to set the level 1 or 2. 2 will show that the packet is delivered exactly once, one and only once. But in the case of the, if I set the quality of service as 1, then it will deliver at least once, but with the probability that more than once also it can be delivered to the destination. So 2 will make sure one and only one. One will make sure at least once. Maybe more than one is also acceptable when you set the quality of service. So when you set this quality of service, your publisher will ensure that your data gets communicated in a proper, efficient manner following this quality of service level. Now, INA. INA is a IAN, Internet Assigned Number Authority. What they have done, they have designated the port number 188X series exclusively for usage of the MQTT protocol. So I can have the, once I start the publisher, I can start on the port number 1881, 1882, 1883, and so on and so forth. Similarly, if I want to have a secure routing, if I do not use the encryption protocol, but I want to use a secure socket layer communication, then what I will do, I will use the port number 888 series because that is registered by to the INA for MQTT over the secure socket layer communication, what we call SSL layer communication for the MQTT protocol. Now let's look at another diagram to have a better understanding how will the architecture work when I use the MQTT protocol for communication of the data, for the routing of the data in the IoT ecosystem, message queuing, telemetry, transport. This diagram we have already seen, so we can move on to the next diagram. Yeah. Now initially we will have one server located at a place where it is accessed across globe from multiple number of vendors, from multiple number of devices without any problem. So my objective is clear. I am having a server at a location where it can be accessed by multiple number of entities. Now this server can have one broker. Now broker is a software entity, not a hardware entity, whereas server is a hardware entity. So it can have one broker inside it, or it can have multiple number of broker inside it, right? Now on the left hand side, I will have an entity called publisher. Now, publisher in a real time will have a sensors, IoT device with a multiple number of sensors, which will be deployed in a real time environment in a hostile conditions. For example, in the desert region or in the mountainous region or on the ocean seabeds. And they are the ones who are going to capture the data. So publisher will capture the data. Once it will capture the data, it will publish to the broker. That means a registration of that particular record will be done onto the broker window. So broker receives the messages which are actually being captured by the publisher, and on the right hand side you can see multiple number of subscribers. Subscribers will register with the broker for the appropriate number of topics. So I can have one subscriber, I can have two subscribers, or I can have hundreds and thousands of subscribers which are all being registered to the broker, which are all being registered with the broker. So broker will maintain a table. Now, what it will table contain? It will have a topic called uh, multiple number of parameter like atmospheric temperature, pressure, humidity, soil condition, and so on, so forth. Multiple number of the column headings will be there. It will also have the values inside it. For example, if I'm running an experiment for what say measurement of the atmospheric temperature, pressure, humidity, soil conditions in the desert region of Rajasthan or any other desert region of the Indian state. Then on the left hand side, under the topics, I will have the list of topic registered. On the right hand side, I will have the whole set of the values corresponding to that particular topic, right? I hope I'm able to connect with all of you and I'm able to communicate the scenario that will exist in the real time, how the table is maintained by the broker. So you can have the multiple number of topics and you will have the values corresponding to that particular topic being maintained in that table. That is how typically it look like. The concept is very similar to the way the broker works as a property dealer in a colony. For example, I am the homeowner. I've got a property which I want to rent out to the tenants. Like I've got a 1 BHK, one bedroom, hall kitchen, or 2 BHK, two bedroom, hall kitchen. What I normally do, I go to the property dealer and I say, I've got a property which I want to rent it out. Kindly register me. So the property dealer, who is a broker, will ask me that what is the dimension of my 1 BHK? Is it furnished, semi-furnished? What is the type of flooring exists? Are the cupboards there in the room or not? Are the ACs fitted on the room or not? So they will ask me all the data, and accordingly, they will ask me what is my expected rent which I want. 10,000, 15,000, 20,000, 25,000. Accordingly, they will keep it. Then they will say, okay, sir, I have noted on your telephone number. If at all I get any tenant, I will ring you up and we'll set up a deal, right? Now, let's come to the right hand side. There are tenants who are on the lookout for a property in the same colony. So what they will do, they will reach the property dealer that I want a 1 BHK, let's say of 10,000. I want a 1 BHK of let's say 15,000, which is fully furnished, like what we call studio apartments nowadays. So the broker is managing the property, or it is setting up a deal between the homeowners, the landlords, and the tenants, what we say kiraida. So we need to set up a deal. So broker will receive the information about the property from the homeowners, register in their register, and then they will also approach the prospective tenants. And maybe if the tenants come first, you do not have the appropriate property matching to them, you will tell to the tenant that okay, you make your request to me, you register your request, as and when I get a proper property information matching to your requirement, I will call you up. So what is the broker doing in that case? It is setting up a deal, setting up a negotiation between the prospective homeowners and the prospective uh, tenants. So that's the same thing here being done. Broker communicating or helping the publisher and subscriber to receive the communication from each other. They will never see to each other. The broker is the one who will manage the communication between them. Now, once you're doing a communication between them, uh, multiple issues will come. I can increase the broker, I can decrease the broker, so I can work on scalability aspect. I can increase the publisher, I can decrease the publisher, I can work on the scalability of publisher. I can have low number of subscribers, I can have more number of subscribers that working on scalability of the IoT ecosystem. Means the system should be dynamic, it can be tuned up, it can be tuned down, to ensure that the system still runs seamlessly, system still runs smoothly without any problem. And that scalability play a very important role in ensuring the smooth functioning of the IoT ecosystem. Now, beside the scalability, another important aspect comes out the security or the reliability of the data. Because I need to protect my data from the hundreds and thousands of intruders, what we call hackers in the real-time scenario. So if you take the same diagram again, there are hundred and thousand of hackers, and you might some hackers might be known to you, but you are not able to do anything because we know in the domain of computer science the entire data is logical in nature. So I know there are hackers. How to protect my data from the hacker? Because the system is being there are hundred and thousand of hackers which actually intruded into your system. They have breached. There is a loss of the pilferage has taken place, security breach has taken place. Now, we as an administrator of the IoT ecosystem own that responsibility that we need to protect our data from the hundreds and thousands of these hackers who are actually prying, who are actually maneuvering over the data which is being flowing between these sensors, between the devices in the IoT ecosystem. So one of the biggest challenge is how to protect the data from these hackers. Any doubt regarding whatever we have discussed till now before we start with the simulation work? Anything not clear in it? Anything, any topic? Okay. Assuming everything is fine, maybe or we can take the queries in the end, Q&A session. Now let's come to the simulation aspect, how we are going to do it. So let me discuss the code because that will make sure that the things are understandable to you. Yeah. Now here is a code visible. Anyone can say yes or no. That will give me the idea that yes, you are able to see
Yes,
the
sir.
code. Fine,
Yes,
fine,
sir.
fine.
Yes,
Good.
yes.
Thank you. So here, the code I have written is in Java programming language. Now, Java offers a API called Java Cryptography Architecture, what we call JCA, and it also offers something called Java Secure Socket Extension Programming. So let me write the same thing here. What I am saying, there are two APIs available here. One is a JCA, what we call Java Cryptography Architecture, so that you can actually correlate to what I'm saying. And the other is a JSSC, Java Secure Socket Extension Programming. So they are the two flavors which are now being used extensively for when you're working on the security and reliability, on the scalability of the data in the IoT ecosystem. Secure Socket Extension Programming. So one is a JCA and the other is a JSSC. So what I have done here, I'm using a JCA and later on in the program I use a JSSC. And there are in the JCA package of the Java, lot many number of predefined packages exist. Like we say import java.security.star. Now what does that this line means? Import all the classes. So those of you who are not comfortable with Java programming language, you'll be able to understand. Import all the classes of the security package by when we write the import java.security.star, then java.javax.crypto.star, javax.crypto.specification.star, java.io for input output activity. Now here I am in this. What is the main objective of this program? What if I write a aim to ensure safe and secure transmission, safe and secure transmission of the data, uh, safe and secure transmission of the data in IoT ecosystem. And which is the protocol I'm using? MQTT protocol. So I'm using a protocol message string transfer protocol to ensure that safe and secure transmission of data happens in the IoT ecosystem. That's what my main aim or the objective of writing this program is. So for that, Java also makes sure that when you're writing such a program, the exceptions are going to happen in the real-time scenario. So there are multiple number of exception classes. Now these are being used as a precautionary measure. You may not require them in the real-time scenario, but what if happens your sensor is not able to capture the data in the real-time scenario, or if it fails in the real-time scenario? So I need to handle the matching exception classes, which will take care that my code does not fall flat, code does not break down, software does not crashes up. So I need to make sure that my data is well protected, well managed, well integrated, well bonded, and it doesn't break up in between. Then there are line number 18 to 20. I use the package called MQTT version 3 protocol. I import all the classes, all the interfaces of the PAHO client. Now, PAHO client is a IoT client introduced by the Eclipse. Again, Eclipse is a free of cost open source IDE which is used for writing the Java programming. Therefore, the writing the Java program for the IoT ecosystem, they introduce a client called PAHO client, PAHO client. So what I'm doing in the line number 18 to 22, I'm importing all the classes, all the interfaces belonging to the PAHO client being provided by the Eclipse. Now, if you look at them, all of them follow version 3 programming, Mosquito version 3 programming. So Mosquito client, now since MQTT has a spelling very similar to the Mosquito, so we also call it as a Mosquito protocol programming, MQTT, message queuing, telemetry, transport protocol programming. So Mosquito client, Mosquito connection options, Mosquito exception, Mosquito message, and memory persistence. So multiple number of the classes that exist within the which are being provided by the PAHO client of the Eclipse IDE. Then we are going to importing all the classes and interfaces of the java.util package and of the SQL, right? Then we start with the actual code. So I define a class called as the IoT device class. Now here, that's what again I've written the objective secure the routing in IoT using the DES algorithm. Now here I'm using the data encryption standard algorithm because I want to secure the routing. How to do the secure routing? I'm using a protocol called MQTT. Good, fine, use the protocol called MQTT. But MQTT will only help in the routing of the packet. But how to secure the data? You need to use some of the algorithm for it. So I can use either the DES algorithm, data encryption standard algorithm, or I can use the RSA algorithm, Ravish Shamir Edman algorithm, and so on and so forth. So in this program, I'm using the DES algorithm for the secure routing of the data in the IoT. Then I come to the class definition. In the line number 31, I define the main function. Now in Java, everything starts from the main function. That's a nerve center of the my program. So public, why public? Because so that any classes and interfaces of the same package in Java or across the package can access my main function. Then we define the function as static. Why static? Because if those of you have done C++, in C++, the main function is outside the class, right? So I can instantiate the class within the main function, and then I can make a call to the functions defined inside the class directly from the main function with the help of the object of a class which I'm defining in the main function. So my operating system, my environment is directly able to access the main function because it has been defined outside the class. But what James Gosling has done in Java programming language, he has encapsulated the main function within the class. Now, how will the Java runtime environment, JRE, which has got Java virtual machine inside it, JVM, be able to call the main function because main function is boxed within the class. So I have to make main function independent of the object of a class. And how do I do it? By making it static in nature. Because then only JVM will be able to access the main function. Otherwise, it will not be able to access the main function. I hope I'm able to clear the point that why we are declaring the main function static in nature. Then, since the main function is not returning anything, I declare it as a void type. Now, we need to receive certain parameters as the input from the user. So we receive them using an array called string args. And if any problem arises, I am ready to throw the exception of the type exception class, right? Throws and the exception. Now, when I start the program, I want to compute that what is the total time taken in the encryption and decryption of my IoT data using the DES algorithm. So I start the timer. So I can see here, I start with the nano, I make a call to nanotime function of the system class, which will trigger the timer. And I am starting a timer, and then it will compute how much time it has taken to execute the program. Now, since I am working on the security of data, on the scalability of the data, I receive certain parameter as an input from the system administrator of the IoT ecosystem. Now, either I can receive as a manual input, or the input can be provided directly by using any of the devices. That both. Now, in this program, I'm receiving the input manually. So what do I do? If you look at that line number 26, I declare a variable topic of the type string class. And I take the IoT temperature record because I'm assuming that I have deployed my IoT device in the desert region of Rajasthan, and I've been given a task to measure the atmospheric temperature. So what is the date on which the temperature is being recorded? So I receive the input from the user. What is the time on which the record is being recorded? So arg0. Now these are the runtime argument. I'm receiving the argument as an input from the user. So arg0 indexing start from 0. Then what are the device latitude coordinate? So I receive
Uh,
them the
Excuse me, sir.
yeah, please go ahead.
Sorry to interrupt you, sir. Could you please switch on your video and present the session, sir? So you want to take a screenshot.
Sure, I will.
Yeah. Thank you, sir. Thank you.
So device latitude coordinates are there. Let me let, I have to check whether my video is working or not. Let me see.
Okay, sir.
Because most of the time we can do it using a switch off
Oh,
slide.
okay, sir. But you are presenting, you also
Yeah.
need that.
I- Let me complete the session first, and then I can explore, right?
Oh, no, but while presenting along with the
Okay.
video is needed, sir.
Let me complete the code part, and then again I will do it. Or let me then explore.
Oh, okay, sir. Fine.
Just, let me complete the coding part first, so that if you have got any doubt, we will discuss.
Okay, sir. Okay.
Coming back to the code. Is the code visible? Can you please tell me yes or no?
Yes, sir.
Fine, fine. So now my device is being IoT device is being positioned logically in some desert region of Rajasthan, right? So what I am doing here, the latitude coordinate of that particular device. Now, one option is that it is automatically detected by certain API and is being provided as an input here. Or I read the latitude coordinates and then I manually input it. So when we work in the IoT, there are two tracks. This one is a software track and one is a hardware track. Now here I am only showing a simulation on the software track, assuming that the hardware is there in place, it is capturing the data and the data is being fed or data is being as an input to this particular Java program. Then what is the longitude coordinate of that particular device? So again, I declare a variable of that type string class args4. Then what is the current energy level of that particular IoT device? I record them or I measure them and I store them and I receive as input from the args5, right? Then what is the type of sensor? Atmospheric temperature or pressure or humidity, seismic vibration, earthquake monitoring. What is the type I'm using? Now in this program, I'm only focused on the uh, temperature type sensor. So sensor type will be all the temperature, actual temperature which is being recorded here. Then what is the device ID of that particular IoT device? So these are the 8 parameters which I receive as an input from the IoT administrator. or the administrator managing the IoT ecosystem, or from it can be manually input or it can be automatically recorded by making call to the APIs which are being provided by the vendors of those IoT sensors and IoT device. Ultimately, we are going to get the data, right? And my focus will be on the secure transmission or the secure communication or secure and reliable communication of the data between the devices. Now, in the what do I do in the line number 45? Or I concatenate all of them. So by making a call to concatenation operator, I append all of them: arg0, arg1, arg2, arg3, arg4. Args mean arguments, and 0, 1, 2, 3, 4, 5 are the indexing. So when I will provide as the input, I will show you, I have created one sample record from the data set. I will show it you as input to you that shows today's date, 13th September 2025. Then what is a time, 4 p.m. So 1600 hours. Then what is the temperature, 24.54 degree, 1 degree Celsius. Then what are the device coordinate, latitude, longitude. Then what is the energy level of the battery, 7 milliampere hours. What I'm trying to sense, the temperature. And then what is the device ID? I say 4999. So this is a sample record which we are going to provide as an input to this Java program. And this is what I'm going to encrypt using the DS algorithm. Now, quality of service, I set the value as 2, which I just shared in my program. Now, broker is being hosted on my device here. In the real time, it will be the IP address of the server. But since I'm running the broker locally on my system, I am giving the IP address 127.0.0.1, which is the default loopback IP address of my system. And the port number which I'm using here, 1885, because all the port numbers of the MQTT protocol works on 188 series. Then I specify the client ID subscriber 127.0, because these are all the loopback IP address of my systems as such, right? Then I make a call to one argument constructor of the memory persistence class, because I want to make sure that the data remains safe during its process of transmission object also between the objects. So persistence of the data in terms of objects when it is being shared between the devices, for that we make a call to the memory persistence class. Otherwise, there's no need to make a memory persistence class. Then I declare a few more variables like PT and CT. I initialize the value to null, not much of significance. Then come to line number 54. We make a call to three argument constructor of the Mosquito client class, MQTT. One is a broker, one is a client ID subscriber, and one is a persistence property, which I have just called it as such. Now, the constructor of the class will be called, it will be initialized, and the default and the value which is being returned is stored in a Mosquito client variable called sample client one, right? Now I generate the publisher. Now automatic generation of publisher is being done. I do not hard code the values. So what I do here, I make a call to the function called generate client ID, which belong to the Mosquito client class. It will automatically generate the ID from me. So I'm not hard coding any value. I'm making auto random ID generation. So if you generate the ID and store into a string class variable called str1. So after the line number 55, either will have a unique publisher ID getting generated, or it will throw me the exception. Now, if it is able to generate it, so I can now display the value generate publisher ID is, and I display the value of str1. So if you look at this diagram, what I have done here, I have generated the publisher ID. Let me go to this diagram. Yeah, this is on the publisher. I have not hard coded the value. I have done the automatic generation of it. Publisher ID has got generated. Now my focus should be on broker and on the subscriber, because if you see this diagram here and if you understand this diagram, same thing I'm implementing with the help of the writing a code in a Java programming language using a Java cryptography architecture, where I do the routing using the MQTT protocol programming, and the algorithm used for securing the data, the DES algorithm, right? Coming back to the code. Yeah. So now I have been able to generate the publisher ID. Now I again make a call to the three argument constructor Mosquito client class, because now I need to generate the sample client 2. So I pass broker, str1 contains the value of the publisher, and I ensure the persistent property is set to 2. So now I get my sample client 2, right? So two clients my ready are. Now I set certain connection options. So because I'm going to use certain options in the next 3 lines of code, so I make a call to no argument constructor by making call to the mosquito connection options. Now, if it is successful, it will return me the information, the connection option reference variable. First thing first, I set the duration of the session. So connection timeout, and I pass the value 60 seconds. That means for 60 seconds, the connection will remain alive between the publisher and the subscriber. Then what do I do next? I make a call to the mosquito version. So connection option dot set mosquito version. Now here I specify the version of the MQTT protocol I am using. So mosquito connection option dot mosquito version underscore 3 underscore 1. Then I clean the session because there are certain garbage collection properties. There might be certain primitive values lying open in the session. I need to clean them up. So I say connection option dot set clean options, and I pass the value as true, right? So I make sure that my session is alive. It is connected. I set the duration as 60 seconds. I set the version of the MQTT protocol, and I clean the session. That is what I am done till now part, right? Now, what do I do next? I say I'm going to connect to a broker. So publisher will get connected to a broker, right? So sample client one dot connect, and with all these connection options, the publisher gets connected to a broker. Again, if you connect to relate to a diagram, publisher is getting connected to the broker of the server, right? So now the I also need to make sure that publisher is linked to a topic, right? So sample client one dot subscribe and the topic. Now topic here, what is the topic here? Topic here is the temperature. If you look here, right at the if you look at the topic class variable, string topic, it's called IoT temperature record, because that is what actually it is meant for. I'm going to monitor or record all the values relevant to the IoT temperature record. So that is what my topic. So publisher is linked to a topic, and then subscriber and publisher all connected to. So subscriber publisher gets connected, the subscriber gets connected with the whole set of the connection options. So sample client 2 dot connect and the connection option. So by the line number 71, my publisher is generated, my subscriber is generated, and both of them are connected to the broker with a set of topic, and the topic is the temperature, because that is what the publisher will print the value of temperature, subscriber will receive a notification for that corresponding value. And between the two, I will secure the data using the DES algorithm, data encryption standard algorithm, which I will just share in the next line of code. And all the routing is being done using the mosquito protocol, MQTT protocol here as such. Now, let's understand the code for the Java cryptography architecture code. Now here, what do? I make a call to the get instance function of the key generator class, and I pass the input of the DES algorithm, data encryption standard algorithm. If this line of code is successful, it will return me a value which I'm going to store into a key generator class reference variable called key generator. So this is a class name, this is a reference variable name. Now using this reference variable, I make a call to the function called generate key. It will uniquely generate a unique key value for me, which will be random and belong to a key of the DES algorithm. So this line of code will return me a value, a unique key, and which I'm going to a secret key class variable called my DES key, my data encryption standard algorithm key, right? Then I will declare a DES cipher variable belonging to a cipher class. Then what do I do next? In the line number 82, I get the instance for doing the padding. Now in networks, we know when we have got a large amount of data packet size and you have got only small data to transfer, you need to pad that packet to make sure that your packet becomes complete, right? So I use a data encryption standard algorithm. ECB is electronic code block encoding scheme, and PKCSY padding scheme. And now I pass this parameter to the get instance function that will make sure that the required padding of the data is done. All right. Then we come to the line number 85. Uh, Now I start working on the initialization aspect. I start working on making sure that the encryption mode is on. So DES cipher dot init is the name of the function, and then I pass two parameter in it. Cipher dot encrypt underscore mode. Now encryption is going to be turned on. So for the cipher, you turn on the encryption. So encrypt underscore mode. And the key which is being passed is currently in the my DS key. So I'm starting the encryption mode and I'm using a key called my DS key. Now, the data which I've got here is in the byte array. So I fetch the bytes from it. So what do I do? Now, what is the content containing? Content, if you look at this parameter here, my content variable currently contains all the information about the device, the energy level, and the value of the temperature. So what do I do from the content? I fetch the bytes because right now the content is of string type, but the algorithm DS algorithm is byte oriented. So I need to fetch from byte from the string. So I say content dot get bytes, and I store into a byte array called as a text, right? Now what do I do? I am now set. Now entire situation is set for encryption of the data. Now this line of code will make sure that the data gets encrypted. So I make a call to the do final function that works on the text. What is text here? The byte array that is currently containing the byte equivalent of the string, right? Because that is what I've done in the get byte function. And I make a call to do find function that will encrypt the data and store into a byte array called text encrypted. So this text encrypted is actually containing the encrypted content of my input text. And now since I converted the string to bytes, now I am converting back from byte to string. So text encrypted, I make a call to the toString function over the text encrypted variable and store into a plain text variable. And I say that yes, my text is encrypted here and it displays the value of the text encrypted. So system.out.println, it is very similar to the printf function of C or cout function of cout operator of C++. That's a way how we display the string to the end user in using a Java programming language. I display text is encrypted and display the value back to the user. And I say encryption is now over. Now, the subscriber, if you look in the next line of code here, what do? I use a make a call to the mosquito message function, one argument constructor of the mosquito message. And I pass this test encrypted as a parameter to it. I set the value of quality of service, right? With the value 2. And now publisher publishes that message, the encrypted message for that corresponding topic. So I say sample cloud 2 dot publish topic comma message. And then we say encrypted message has been published. And the publisher now disconnects. So publisher has encrypted the data, printed onto the broker of the server. Encrypted message has got published for that particular topic, and then the publisher gets disconnected. So we display the same thing back to the user. That publisher is now no more a part of the active system. Now the subscriber will come to the picture. So if you look here, subscriber receives a topic and the encrypted message and starts a decryption. So subscriber has received the encrypted message from the broker, but in this encrypted format, how it will make a use of it. So it will decrypt it. So how to do it decryption? I start the decrypt mode on. So I make a call to the init function of the DS cipher and I start the decryption mode. So I say cipher.decrypt underscore mode. And for the same key, because I'm using a symmetric, DES is a symmetric cryptographic algorithm, which uses the same key both for encryption and decryption. So you cannot change the key value. If you want to change the key value, you need to use the AES or other RSA. You have to use the RSA algorithm because RSA uses two pair of keys, public and private keys. Symmetric cryptographic algorithm, DAC and AES use the same key, both for encryption and decryption. So what do? I make a call to do final function and I pass the encrypted text as the parameter. Who does it? Subscriber does it. Now it will decrypt the text and the decrypted text is displayed to a byte array called text descripted. Now since it is a byte array type, I need to convert into a string. So I make a call to toString function over the text decrypted. Now why I am doing byte to string? Because Java supports the string. C and C++ supports a byte-oriented character set. Java supports Unicode character set, 16-bit wide character set. So Java understands what the strings are. So that's why I need to do the conversion. So I run a two-string function over the text decrypted, and it returns me a CT variable, so ciphertext variable. And I said text decrypted is new string using a text descriptor. So making a call to one argument constructor of the string class and displaying the value of text descripted as a parameter to it, so that the string is visible to the subscriber. Once it is being done, I said decryption has been over. So in the line number 114, we have been able to, publisher has been able to receive the record as an input from the user, encrypt the data, publish to the broker, vanishes from the screen. The broker sends the notification to the subscriber. Subscriber receives the data, decrypt it, and display it back to the user. And then now we stop the timer. We say system.nano time. Anyone saying anything? Okay, fine. So now I stop the timer here and I subtract the time, end time minus start time, and I display this is the total time which has been consumed in the execution of this program. And then I exit from the program, system.exit. If at all there are certain exceptions that will be arisen, I have got a matching exception class ready, like no such algorithmic exception, no such padding exception, invalid key exception, illegal block exception, and the bad padding exception. They might be used, they might not be used, but I am sure that yes, I am ready with my corresponding data. Now let's see how to execute the program. So what I do here, I open the command prompt window, right? Uh, Let me, yeah, I've already done it for convenience, so I can just directly show it to you. Now, first and foremost, what I do here is that I start the Mosquito server, the Mosquito protocol programming. So in my program files folder, you see I have already downloaded the Mosquito. It's free of cost, open source on the web. You can just go and access it, or if you want to have a look at it, just a moment. I will show it to you how to do it so that you can actually see it. Code we have already discussed. So let me see. Yeah. This is a Power client which I was talking about. So you need to download it from the web. There are download links available here. Because of the paucity of time, I will not be able to showcase everything. You can see here, it's a protocol primarily meant for carrying out a communication for the IoT devices. Then we need to download the Eclipse Pahoo client. I will share the links in the chat window. You can go through the links. And again, you can download the Windows version, or if you have got an Apple Mac, you can download the Mac version of it. So you need to use both the links for downloading them. I have only downloaded on my system, so I will just share the same location to you so that you don't have find any problem. Let me see. Yeah. We can go to the C drive, go to the program files. I have downloaded the Mosquito protocol here. I just press, yeah, Mosquito, you can see here. Oh, God, it's further reducing now. Yeah, Mosquito folder will come. And I've got a Mosquito here. If you can see here, the application. So, yeah, we have Mosquito here. This application I'm going to launch. So once you download the Mosquito protocol from the web, also open source protocol, this folder will come onto your system and now you trigger it up. So what I do here, I go to the folder, yeah, program files, Mosquito version V is a verbose mode printing, P is a port number, and 1885 is a port number on which I'm pinging the Mosquito protocol. So you press enter and you can see here Mosquito version is starting using default configuration, starting in the local only mode on my system. Then create a configuration file. For more details, it will refer to the Mosquito URL. It is opening both the socket, opening IPv4 listen socket in the port number 1885, opening IPv6 listen socket in the port number 1885, Mosquito version is now running on my system and the cursor is blinking. Now what I can do here, I can go to the open another command prompt window and I compile the program which I have written, the IoT device.java, which you have just seen the code of it. I compile the program using a Java compiler, Java C, IoT device.java, and I execute it. So for execution, I will be requiring the values which I have written in the program. So I will just copy it from there, or in the real time, you can manually either input or you can use certain records which can, like the QR code nowadays come, you will fetch the value and input directly to the program. So what do I do? Java IoT device, and I pass the runtime arguments value here, right? Today's date 13 September 2025. Then the timing 4 p.m. Then latitude and longitude coordinates. Then the energy level of the IoT device 7 milliampere hour. Then the temperature. Uh, and then file a device ID all 999. Now, what it will happen after the execution of the what will happen? I will just show it to you so that you can correlate with the output of it. Yeah. If you look at the program execution, generated publisher ID. Publisher ID has got generated with the unique PAHO client number, PAHO, and the details of it. Connected to the broker. Broker has got initiated on my system on the port number 1885. Subscriber has got connected. Whatever input was given, it has been encrypted using the DES algorithm. Encryption has got over. Encrypted message got published. Publisher has got disconnected from the system. Received message from the broker. Now subscriber will react. The subscriber has received this message from the broker. Now subscriber decrypt the message. So this is a message which has got actually got decrypted from the broker, from the subscriber point of view, and it is exactly the same message which has been published by the broker. So broker subscriber will now communicate with each other with the help of broker. Publisher and subscriber will communicate with each other with the help of the broker. Broker will act as a connecting link, and the encrypted message is being shared with them using the MQTT protocol. And how I have got encrypted using a DS algorithm. If I may be able to do it, actually decryption is over. In the total time which has got consumed during the entire process, I display in terms of the nanosecond, and then I get back the window here. So in on my device, on my laptop, I have been able to configure because this is a simulation. The publisher window, the broker window, as well as the subscriber window, and they've been able to communicate using the MQTT protocol. So with that, I would like to close down my session. If there is any doubt, please feel free to unmute yourself and ask me. I will be happy to take the queries. Any doubt, any queries?
Sir, can you please
I'm sharing the link in the chat window. So those of you who are interested can download the Mosquito protocol and do the programming.
sir, please on the video, sir.
Video I tried. Let me try again. I think there's some problem with the device setting.
Okay, sir. Try if possible, sir.
Yeah. Let me try.
Participants, if you have any queries,
In case there are no queries, I'm sharing my mail ID. So if you have got any doubt regarding the topics I covered in today's session, you can drop me a mail. I will happy to take the queries, or you can text me on my number. I will happy to answer your queries.
Okay, sir. Sure, sir. Thank you for your accepting and your valuable presentation, sir. Thank you so
Uh,
much.
pleasure. Pleasure is all mine.
Thank
Thanks
you so
me.
much, sir.
Thanks for having me.
Okay, sir. Thank you, sir.
Okay, then I take a leave. Bye.
Okay, sir. Good evening to all. Now, the last session, our resource person is Dr. R. Rajasudarshan, Assistant Professor, Velammal College of Engineering and Technology. The topic troubleshooting common issues in battery monitoring system. Welcome you, sir. Good evening, sir. Um, I invite our department staff, Mrs. Mahalakshmi ma'am, to introduce our resource person. Ma'am, can you please introduce him, ma'am?
Yes, sir. A very good evening to all for this wonderful event. Myself, Mahalakshmi, Assistant Professor in Christ College of Engineering and Technology. It is my honor to introduce our distinguished guest, Dr. R. Rajasudasan. He is a highly accomplished academician and a researcher with over 11 years of combined teaching and industry experience in the field of VLSI design, digital electronics, IoT, embedded system, and related domains. He currently serves as an associate professor at Valamal College of Engineering and Technology from February 2025, following his tenure as head of department and associate professor at Sri Shanmuga College of Engineering and Technology 2022 to 25. His career also spans roles as an assistant professor, junior research fellow in industry, and teaching assistant. He holds a PhD in VLSI design from Kalasalingam Academy of Research and Education, where he also completed his MTech in VLSI design with first rank and gold medal, and a BTech honor in EC. An active researcher, Dr. Rajasudarshan has published 36 articles across reputed journals and conferences, including 5 SCI, SCIE indexed papers, 26 Scopus indexed works, and contribution to Web of Science. His research spans FPGA implementation, biomedical signal monitoring, IoT application, machine learning, and advanced IC placement techniques. He had also authored 2 books, A Deep Dive into Python Programming 2022 and Wireless Sensor Networks 2022. His expertise is backed by strong technical proficiency in programming, C, MATLAB, Verilog, VHDL, and design tools such as Cadence, Mentor Graphics, Xilinx, FPGA, boards, COMSOL, Proteus, and more. Dr. Rajasudarshan's research has attached funded project worth over rupees 12 lakhs, including grants from the Department of Science and Technology and the Entrepreneurship Development Innovation Institute, Tamil Nadu. His contributions have been recognized with accolades such as the Best Researchers Award 2021 and a first prize at Ableist Shastra University 2022. A dedicated mentor and academic leader, he has delivered lectures, workshops, and FTPs on topics like VLSI, embedded systems, IoT, and research methodology. His memberships include IEEE and IETE, reflecting his active involvement in professional communities. Beyond academics, Dr. Rajasudarshan has interested in sports, particularly cricket, and has participated in athletics and marathons. He is known for his confidence, communication skill, and motivational approach to both teaching and research. Now, I warmly welcome our resource person, Dr. R. Rajasudarshan, to begin the session on troubleshooting common issues in battery monitoring system. Now, I hand over this session to the resource person, Dr. R. Rajasudarshan, to start the event about troubleshooting common issues in battery monitoring system. Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you so much for giving this wonderful introduction about me. Is the screen is visible now?
Yes, sir. Visible, sir.
Oh, okay. Thank you, sir. Thank you, sir. Let me start with the session. That is your final session of this wonderful FPP, which serves the many researchers and academicians. And let me start with the title called "Troubleshooting Common Issues in Battery Monitoring Systems." And this particular BMS plays a vital role in EVs and other electronic vehicles, which has a heart of your device. Say called mostly lithium-ion batteries is commonly used for EVs as a battery to protect and to safeguard the vehicle instead of using the fuels. It is plays a vital role, and because of this particular BMS, it protects the batteries from overcharge, overheating, and failures, extending lifespan and preventing disasters. These are the main ideas about BMS, which has the task of overall continuous monitoring of failure assumption and preventing disasters. And let me go with what first of all, we know what is battery monitoring system. It is an intelligent monitoring where it tracks the voltage, temperature, current, and SOC of battery cells in real time. And it also controls the charging and discharging balances to optimize performance and ensure uniform operation where the particular BMS plays a vital role. And this particular the process will make sure that the lifespan of the battery will be go longer. Next is and it also acts as a diagnosing health for the EVs to protect the entire vehicle without harming the entire operation of the process. And the core function of BMS is nothing but it monitors it is real-time monitoring, cell balancing, and protection systems communication interface where it communicates the data and it will transfer the information from one end to the other end with the help of different communication protocols where it also tracks the voltage, temperature, and its lifespan regularly to the host and even from the remote areas to continuously monitor the batteries. So why? Because even in the Ola electric vehicle, for example, I should say yes, it automatically when you run the vehicle, the battery gets heated. So there's a separate cooling system is also available in the device. But even then, the battery gets heated. So this has to be monitored continuously, and this battery charging and discharging should be as per the duty cycle. So this particular duty cycle is monitored even from the in the remote areas. That in that way, this communication protocols plays a vital role, and which helps the batteries to get overheated. And next is key battery states monitored is that as I said, it's state of charge, state of energy, state of health, and state of power. See everything that is percentage of availability of capacity of accurate range and runtime. That is, runtime is very much important for a battery to get charged and discharged. And this is particularly monitored in the state of charge. And state of energy is nothing but it evaluates the optimization of performance and unexpected shutdowns. It should not automatically put down all those energy down or say called voltage drop of the batteries. And it also batteries and it also monitors the battery aging and degradation patterns to predict the maintenance needs and replacement timings. State of power is to monitor the delivery capability of demanding applications and peak performance of their batteries. And these are the advanced features and alerts which is given for the BMS to get operated. So it depends upon the data science of historical data achieving, data alert system, and centralized management. These three tasks, which is plays a vital role for battery monitoring systems, and it has been followed by major industries. And BMS in electric vehicles is a critical role. So he called, first of all, you should manage thermal management, range optimization, and smart communication. That is to control the thermal systems to maintain optimal battery temperature during fast charging and high power output scenarios. Next, I should go with range optimization is that precisely balances cells to maximize the driving range. And for example, maximum driving range is something, but for example, if batteries get charged 100%, it can run through at least 200 to 300 kilometers. So that should not get reduced. If it does get reduced, there's a problem in battery. So that particular run time is being calculated, is being continuously monitored in the battery monitoring systems. So that is a that so that range optimization so plays a vital role after the thermal management. For example, if we take through 300 kilometers uh, with a single range with a single throw, if it does so, then automatically the battery gets heated. So we have to give a halt or pause to the battery to get cooling up, and again to charge up. Then you can make use of the entire charge for your throwdown. So this has to be in this perfect aspect ratio between your thermal management and range optimization. And next is smart communication. That is automatically it involves a seamless interfacing of and transferring of data about the range optimization and thermal management to the uh, to the uh, uh, to the charging nodes, where you can identify where the nearby chargeable ports are available. You can easily communicate, and so that also you can get the charge by nearby. And next is that the real world impact. That is how this particular battery monitoring and monitoring systems plays a role in the sense it it prevents from the fire safety. That is, for example, it prevents from 99 point, as per the statistics says that it presents 99.9% fire prevention has been done. It is prevents from catastrophic failures through yearly fault detection and immediate protective action. And 40% extended lifespan has been done with the help of BMS. That is increased battery life and significantly reducing replacement cost and environmental impact. Then for the user concern, it becomes 100% confidence to enhancing experience by providing accurate and real-time battery status and health information. And this particularly plays a vital role for and this impact created by the BMS, especially for all the EV vehicles. So that is a common thing. And then this is all about the EVs. So if you come to the common user related issues, then it becomes that installation is a big problem. Then training gaps, user neglect, data service integration. So everybody doesn't have the awareness of how to install it, what is it trying, how to train, and on how the user to train about the knowing about the batteries, and how to neglect how to use the lack of attention or completely ignoring the monitoring habits to the users. And there's a big gap between the services, so there is no any big BMS engineers in India. So nowadays it is growing up. I should say is in India, this BMS is bit of less today, but compared to the previous days, now it is growing up in a rapid phase. But in the European countries and in the American countries, it is in huge phase. Everywhere you go, there will be a BMS engineer. They used to monitor their batteries. They used to make use of the EVs, and they'll be continuously give trainings to the users to how to install it, how to service it, and how to integrate all those stuffs in the BMS. So this services, this awareness is created in all over. It's in European countries and American countries rather than in India's. In Indian countries, there is very less awareness about your BMS comparing to other major countries of EVs. And there are main drawbacks of this, I should say, yes, comprehensive analysis. That is, most people won't preferring this particular EVs because of the threat of thermal, that is fire, immediate fire because of increase in temperature or increase in voltage or increase in heat dissipation in the battery. So this is a major thing. Everybody, even the topmost people also will be thinking of to buy an electric vehicle and consuming it. Nowadays it is okay, but even though it has been they've been thinking of just because of the safety measures and the awareness created by this and the training given to the service engineers, it is less. So it is a major problem, and there are 300 plus companies who are studying about this, and 60% of and person is ignoring about the BMS, be ignoring the sense they don't have enough awareness of this. So that is a major thing, and next is that 85% improper installation. That is, nobody will be that is a major problem in Ola. So there are two there in Ola. They should be they're getting frequent getting fire. Vehicles get fired because of improper installation and improper awareness of BMS. Yeah. So that is that is battery management system and battery monitoring system is not completely trained for by the service engineers, and they doesn't have enough awareness to create the to this. So there is very less trained engineers on BMS. So that is a major drawback about this BMS. And the technical challenges, I see, let's say it is complexity. This is estimation is complexity, and security risk, and temperament and temperature management. It is three major technical challenges we have in battery monitoring systems, because all are non-linear patterns. So we cannot be able to predict if it is so, if we cannot able to say it in a binary all are non-linear terms. It becomes it depends upon the state of charge, it depends upon the state of energy, it depends upon the state of power, and it depends upon the state of variance. So these particular states plays a vital role for monitoring the batteries, especially lithium ion batteries, which will create a life increase in lifespan and decrease in the problem of technical challenges. So we use commonly uses lithium ion battery. So the common thing you should think is that state complexity is available, and temperature management. It is data security. That is, we cannot be able to get the data completely. That is, there's a problem in the communication interfaces between the batteries and the to the companies. So there is there is no enough communication protocols. So that is the problem. You cannot able to easily track the how many charge has been reduced, how many charge has been increased. So that is a major drawback. And what's the condition of the battery? What is the level of voltage, temperature should be monitored? It is being uh, suppressed, and it cannot able to transfer the data. So that is what data security risk mean. And it is we use lithium ion, not lead acid. The base and the thing is that lead acid and lithium ion plays a vital role. The thing why lead acid is not widely used is because of premature test termination, weak self bypass, and your myth-driven practices. So these three major things, which why we use lithium ion and why not the lead acid batteries. So as I said, it stops the capacity earlier, missing critical performances in degradation of indicators that appear in the latest test phases. Next is a failure to properly bypass weak cells during testing squeeze, overall battery bank assessment, and masking individual cell problems. This is a weak cell bypass failures where you cannot be able to predict the exact failures of this particular type of battery cells. So that is the reason we are going for this particular lithium ion, and this are the dominance why lithium ion is used. That is, despite market leadership, lithium ion batteries present unique challenges, including thermal runways, risk, and complex multi-stage charging profits, files, and that stain monitoring capabilities. I also thing say is that lithium is now apparently available in the Kashmir. That is what we have now nowadays. It is fine that lithium is apparently found out in Kashmir. Was but the problem is that how big that is a raw material, but how do we convert, how do we make use of this raw material? So that's a problem in technology we use. So that's a problem in the infrastructure, technological infrastructure we have, that we don't have any technological infrastructure to convert this raw material to the battery. That is lithium ion. So that is a problem we have. Even though we have raw materials, but we don't have any technological advancements or technological infrastructure to convert that to a problem. So even but even then, we are using lithium ion because of its particular uniqueness of this. We even then because of its extending lifespan, and there's a problem. Even though there's a problem of thermal runways. There's a risk is there. Both lead acid and lithium ion as both risk. So you call it this particular thermal ion waves as more problem in temperature. It may heat at any time. At any time in the sense, for example, if you make use of the torque more, torque in the sense you use, I think triple engineers will be knowing it. If you make use of the torque more, of your vehicle more, automatically the consumption of your battery will be more. Automatically, if it is battery consumption is more, automatically there's a possibility of increasing the temperature and heat dissipation will be there. So to avoid this, we will be having a separate coolant is available. So that we should think is that please think to before choosing the battery, think to the major critical pa- parameters of lithium ion battery. So, sorry, before taking it to the choosing of batteries is that we should think of it in terms of thermal consumption and your say called the voltage, current, temperature, and power. These things we should think. Next is that environmental and life cycle challenges. So critical gap, there's a battery. Most battery monitoring systems operate in isolation from environmental conditions, focused solely on performance metrics while ignored broader sustainability impacts. So next is disposable neglect. That is, we used to neglect the strategies of monitoring the data protocols, they call management protocols and disposable tracking capabilities. And next is recycling gaps. That is, we cannot if we recycle if you use the recycled battery, that is also a problem. It cannot go for increased in lifespan, but we can use to some extent, but it won't be supporting for extending lifespan. And that's the problem of in blindness also. If you use the battery which is recycled one, there's a problem of leakage of acids, so that may harm the human beings in terms of by increasing the it may harm the human beings by especially for the eyes. So that is also we should think about when we going for this. And next, the overcoming the what are the best practices to overcome these drawbacks in the sense. It is training programs, how to resolve the problems. That training to be given for the um, engineers to resolve all those problems. Next is hybrid system architecture, where we can maintaining operational flexibility and scalability. So next, advanced diagnostic algorithm should be there. That is, optimization algorithm should be used. Then what is the machine learning? Machine learning and AI comes to the picture here. So with the help of these terms, with these algorithms, we can make use of this. And next is that, and the industry optimization should be industry standards should be followed. So even though we make all those stuffs, as I call AI, we are integrating AI, which are integrating machine learning. We are integrating some operational flexibility and scalability. We should also adhere the rules of BMS standards to ensure interoperability and security concern also. So that is the best way where we can make use of the to overcome these drawbacks. And key battery parameters to that is, as I initially told that we have to monitor, that is key parameters. We have to monitor state of charge, state of health, cell voltage, temperature, and ohmic resistance. We have these are the key parameters to be monitored by batteries. And the typical troubleshooting scenario, I say alert generated. Uh, Once again. Okay, this was a typical troubleshooting scenarios we have. That is, we should make use of alerts by giving battery report, cell resilience indicating potential failures. And next is that no action, and the operations team should continuously follows the non-critical maintenance schedule also, and cell failure within 2 weeks. because the entire string outage, so that's emergency shutdown will be there. So these are the three troubleshooting scenarios ignored harms. We should not ignore alarms where there's no problem, but there is no any leakage. Even though there's a leakage, small leakage, we should immediately go for the BMS monitoring or BMS service center to immediately to get ready and buy the battery. So these are the installation and commissioning best practices we have. So called proper sensor placement. So called that is see sensor placement is a plays a vital role for accurate data transmission. So that is what ensure the correct positioning and secure wiring connections for accurate data connection and system reliability. Next, we also look for a system calibration, that is to calibrate sensors regularly, and that is mostly required. And along with that, we should make use of how to establish an accurate reference points we have. See, whenever we go for calibration, we should have some annual maintenance report also. So that is to be followed, and that is to be recorded continuously. And testing also. See, before going to the road, the battery has to be tested. Let us perform initial system testing, simulating fault conditions to verify proper alarm and response functions. And also documentation, as I said earlier, documentation should also be there for training purposes, and also to be make use of the other service engineers to look after what is the condition of batteries and how it is serviced earlier, and all those report has to be documented for training purposes and for future services. And next is effective user training. That is what this is a major troubleshooting to that is. As I said here, there's no any training programs. So this particular training programs will help the engineers to get regard of all those stuffs of technical challenges caused by BMS. That is metric interpretation, response protocols, and case study learning. And there's other advanced troubleshooting tools and techniques, that is cell emulators, ohmic testing, curve analysis, and system integration. These are the major troubleshooting tools and techniques where you can study, where you can learn all those stuffs in here, and where you can able to understand the exact condition and status of the battery. So this has to be followed. This has to be note down, and all those particular tools and techniques has to be continuously monitored and continuously to be serviced. Continuously should be documented. These three things should be done by the engineers, especially cell emulators and ohmic testing is in initial level of testing for a BMS to do before getting to the market. If it is so, then it will be good. Else not. So we have to think that, and the system integration and curve analysis and system integration will come to the picture when you train the engineers getting into troubleshooting the techniques. There should be a separate document. So where to and how it is installed, and what is battery used, and what is the lifespan you are given to the battery, and what is the charging and discharging ratio of the battery. And all those things will be covered in curve analysis and system integration. So, along with the sensor calibration points and type of sensor used and number of sensors, and what is the temperature it is connect it has, and the nature of sensors, all those things which is which is continuously maintained as a systems for automated correction of all those tools. Even sorry, if you this all four tools and techniques, it is it is for this supports for even from remote areas or automation also. Even you cannot able to go for remote areas because it is a problem arising in the vehicle. You should take to the center, and in the center they'll be going for automation testing. In the automation testing, they'll be using either OMN testing or curve analysis. These two tests commonly used. And first of all, they'll be going with OMN testing to employ the advanced level testing to hidden cells issues before problems become apparent. So this is techniques we have to troubleshoot all those problems. Okay. Next is that is transforming battery reliability with BMS. That is how much after continuously monitoring the battery, how much it is improved in the sense 70% of failures has been reduced. So we cannot say 100% or we cannot say 90%. That's a problem in 30%. So now, but we are improved. That's to 70%. That is with the help of this battery monitoring systems. It does retrained the entire staff on proper BMS usage and interpretation, implemented strict alarm response procedures with clear escalation, and upgraded installation standards and sensor calibration process. So these 3 points has been strategy has been implemented to overcome the challenges and overcome the problems which is occurred in the BMS. And with that, it is 70% failure reduction has been attained. Okay. So the next is how we can unlock the potential of your battery. That is on the after on the after this full how to the full potential of your battery monitoring system. That is foundation elements, strategic mindset, and cultural integration. That is proper installation. That is what first of all you should everything everybody should mind thing is that proper installation and user engagement plays a vital role to protect proactively troubleshooting, save cost, and enhance safety. And strategic mindset, that is to treat BMS as a vital asset management tool and not as a passive data logger. And cultural integration invest in comprehensive training programs to educate about BMS insights and also how to maintain it as a document and how to maintain it as a remote also. And that is a future trends in battery monitoring. AI integration, that is we used to make, that is nowadays they looking after, even Tesla is looking after this AI in battery monitoring. See, AI is everywhere nowadays. Even so now battery also in the battery also AI is will be integrated, and this has been currently in the research, and it has been widely used by the Teslas and in BYDs in China. And AI integration, that is enhanced, that is advanced artificial intelligence and predictive analytics enable smart fault detection and proactive battery management. So this fault that is what BMS, that is battery. There's a problem we have is how to detect a fault. There's a problem. Then how to manage a battery is a problem. So these two problems will be done with the help of this AI integration and enhanced remote monitoring. That is also is possible. So by giving this AI that is into a picture, expanded capabilities for larger scale energy storage systems and comprehensive EV fleets management solutions. And that is finally the architecture. Yeah, that is to change the architecture with the help of with the integration of AI system to the picture, that is a development of distributed BMS architectures provides unpredictability, scalability, flexibility, and system reliability. So all those stuffs will be taking into account for the redesigning of BMS. That is the rethinking of BMS in smarter way and in a flexible way to get treated in the remote as well as in person also. So that is what this troubleshooting process is all about. If anybody have any doubts, you can ask me. Any doubts? Okay, any doubts? Or shall we wind up? Madam?
Hello, sir. Hello, sir.
Yes, madam. Yes, madam.
You're proceeding, sir.
Yes, madam.
Yes, sir. Okay. Yeah.
Okay, so we have to think in such a way that we are making it in terms of, so apart from this particular in the AI integration, enhanced remote monitoring and model architecture, we used to have other techniques of one humans where used to make the batteries which will be connected into four cells. See each for example, if you take a two wheeler, which is that is a EV two wheeler, we take every battery SSLs. So we make use of 48-volt control, 48-volt battery or controller. We used to make it as the four cells. Each cell consists of 12 volt, which is connected in series version, and each battery will be monitored separately, and for which the entire system is being monitored in the remote area also. So, but monitoring in the remote areas has been difficult nowadays, especially in India. But it is in abroad, it is quite natural. But there's a problem in India is that, as I told, that infrastructure facilities and lack of infrastructure facilities we used to have. So, there's a problem of cha- charger banks, which is not available as like fuel filling. There is petrol bunks or diesel bunks. Okay. So in that way, we used to make that. We used to continuously monitor the battery in terms of how the duty cycle, in terms of architecture, in terms of cells, in terms of cell monitoring, and in terms of power and the power dissipation. All those four parameters has been continuously monitored, and this AI integration will give the possibility of giving the predictive analysis. For example, predictive analysis. What I mean is, if you go for 200 3 meter long, kilometer long with the help of the single battery charging. So if it is so, it can easily predict and display. So after this many kilometers, in that this particular battery will drain out or short will be shut down. So this particular alarm should be given. So this particular alarm, which will reduce the problem of technical challenges, and this will give the insurance, and this will give the insurance that the user will know how when to charge and what to done to the immediate to for the EVs. So that in that case, this particular AI will play a vital role, and moreover, this remote monitoring plays a vital role in the EV fleet management systems. That is, fleet management system solutions plays a vital role for larger scale. We cannot able to take one battery and to get monitored here, to get monitored one at a time. It is not possible. We should make a large scale of batteries, and that will be kept in a tray of cells, and that is monitored based on the parameters, as I earlier told that. So four different parameters will be discussed. That is, one is voltage, temperature, current, and and ohmic resistance. So all those four will be tested with the help of this the help of this tools called ohmic resistance. So that test continues all those after getting initial phase of testing of all those four parameters. Only then it goes to the next level of testing, advanced level of testing. So advanced level of testing, which also ensures the communication interfaces of sensors also. It comes to the picture of it. They discuss about the sensor architecture, and sensor integration with the batteries. All those stuffs will be discussed in the advanced phase of testing. So we have to think that both level of testing will be done. But initially, we're looking after what is the drain capacity, what is drain current will of a battery is loaded, and when to, what is it, charging time, discharging time, and this which is calculated with the help of duty cycle. So all those stuffs will be monitored in only can be remote area if it is large scale. So for small scale, this remote monitoring won't be a bigger task because of its cost and complexity in design, and especially cost wise, it is very huge when you go for small case testing, small level of testing. And when you go for modular architecture, so this particular architecture plays a vital role in terms of increasing in scalability. That is, we can easily scale up with more amount of data. We can easily have flexibility, and reliability also will be increased. If it is flexibility and scalability is increased, automatically reliability also increases. Reliability deals upon the lifespan of the vehicle. So vehicle lifespan depends upon the lifespan of battery. So when lifespan of battery is increased, automatically the reliability of the entire vehicle will get good. So even though there's a problem in the sensor, we can easily cure it, or we can replace it. But if there's any problem in the battery, we cannot able to replace it because it is a heart of the system or a heart of the entire vehicle, and it consumes more amount of energy. And for example, it is a total, for example, if a vehicle is cost around 1.5 lakhs, automatically the battery cost will be around 60 to 70% of the intake cost of the vehicle. So you cannot able to take as easy as like your normal customized vehicle. So this particular vehicle EVs plays a vital role with the help of this battery, and this battery is continuously with monitored, and it has been managed with the help of those different modules and architecture and different tools and techniques to resolve all those problems. Okay. So in that way, you should think is that so before game, and you can also train your students, or you can also train your this also you can also train your based upon this. Okay. So please think that give proper training to your colleagues or students, or ask the students to go for internships in the nearby battery management systems services. Yeah, you can train more, and also you can make use of this particular training session, say called which is available in the Chennai Sri Perumbudur. So in that way also you can make use of, especially Honda, and even Hyundai is also giving training for the internship way. And Robert Bosch in Coimbatore also they are giving about how to make use of this integrating AI in batteries. So that is what they are giving in Robert Bosch, and these are the opportunities where the students and faculty members, even faculty members, is required some industrial trainings as well in the coming days. So we can also make use of this particular opportunity to know and to make uplift our profile, as well as to gain to go with fundings also with the help of this battery management systems. So even Taiwan has been partnering with us. So Taiwan, if Taiwan has comes to the picture, automatically your battery management system, along with it can go beyond China process. China also, in China there's a different BYD. So there's a the industry is there where they used to have separate plant for only battery management system and battery management system. So in that way, even Taiwan is building up a separate plant for it, and India also it is planned, and it has been planned with the integration with the tie-up of Taiwanese companies. So even in India also it can grow up. It will grow up within a couple of years. We hope so. Along with the semiconductor booming up, so if semiconductor on this particular battery monitoring booms up, automatically technological advancements in India will also be booming up in a different way. So think that give importance to all those instead of building up EVs. Give importance. You see, EVs can be built with the help of every engineers, but EV doesn't mean that the entire the outer body. It depends upon the batteries. So fixing up, getting a battery, fixing up it in a vehicle, it is easy. But how to continuously monitor it, how to get the regard of all those problems, that matter. So that should be given proper training, and that should be given proper awareness to the engineers before getting up to the scaling up, or into even for the startup companies. Nowadays many startup companies are there on the or growing up in EVs. So everybody is looking after EVs. So that plays a vital role. Um,
Hello, sir.
yes, sir.
Sir, good evening, sir. Sir, this is
Yes.
Parmesh, sir.
Okay, sir.
Sir, I am a research scholar.
Okay, sir.
Sir, researching on the bulging of battery and SOC estimation.
Okay, sir.
Sir, can I get internship in the companies you listed short ago, sir?
So yeah, okay, okay, that's possible. So even TVS Motors also is giving internship in Oslo.
Oh,
Okay,
sir, can I get?
sir,
Yes, sir, yes, sir.
please come again.
Can I get the address and the person to be contacted? If you could.
Okay, sir, you can contact me in person. I'll be sending all the stuffs to you, sir. So I'll
Sure,
be
sir.
I'll
And
be posting my contact
email
details
ID.
in my in the chat box.
Okay, sir.
So you
Okay,
can
sir.
make use of this,
Yes, sir.
and I'll be giving the contact details of the person to be contacted for this internship.
Okay. Thank you, sir. Thank you.
Thank you. And I have posted my details in the WhatsApp. And so in the chat box, if anybody wants to give and yeah, need any opportunities related to internships or research process, you can contact me. And I can give you some genuine suggestions, and I can give you some genuine companies to get interest in your research progress also, and also funding process. Any others? See, any doubts you can ask me, please.
மூணு பேரு. Hi, sir. Now we'll have a feedback session from the participants, sir.
Okay, ma'am. Okay, ma'am.
So can I invite the participant now? Uh,
Yes,
may I
ma'am.
now
Yes, ma'am.
invite
Yes.
Dinesh Kumar, AP Triple E, Chettinad College of Engineering and Technology, to give the feedback about the session, about the
Yes.
FDP 6-day FDP session.
Yes, ma'am. Yes, ma'am. Yes.
Ma, I think Dinesh Kumar has the network issues might be. So now I invite Ramesh Kumar AP, EC Department from St. Michael College of Engineering Technology. Sir, you can give your feedback. So, Pradeepa ma'am, you raised your hands, it seems. Are you interested to give the feedback? No. So any volunteers from the participants can give the feedback now.
Ma'am, good evening, ma'am.
Good evening, sir. Please.
Madam, this is Parmesh from Mysore, madam. Can I
Yes, sir.
give feedback, ma'am?
Yes, yes, sir. Proceed, sir. Thank you.
Okay, madam. Madam, the internship was really excellent, madam. As a research scholar, I was searching for internship which can provide me all the details regarding battery and battery programming and BMS programming, all those things. From this internship, I got all the knowledge what I was searching for, ma'am. And really, the coordinators and these ones are they were supportive, madam. You people were shared the things for studying and all. Thank you for that, madam. And the resource persons were really they were knowledgeable, ma'am. As I saw compared to other FTPs, this FTP was really I felt very good, ma'am. Thank you for giving this opportunity, madam. Thank you, ma'am.
Thank you, sir. Thank you for your valuable feedback, sir.
Thank you, ma'am. Thank you, ma'am.
So now, may I now invite Shobha ma'am from PSN College of Engineering Technology, Tirunelveli, to give the feedback.
Yes, ma'am. Good evening, all of you. I'm Dr. B.
Thank
Shobha,
you.
Professor and Head Department of Biomedical Engineering from PSN College of Engineering Technology, Tirunelveli. Basically, I am from Electronics and Communication Engineering. After attending this particular FDP, there is 6 days Atal FDP on the topic Introduction to mRuby for e-vehicle control systems, a lightweight approach to battery management. So it's really workful because the topic what they have selected is the need of the hour today. Even though these EVs are playing a major role nowadays, we are facing a lot of difficulties, especially with respect to battery management. So they have taken that particular topic specifically, and all the experts they have done their maximum because they've explained all the topics related to what are the problems with EVs, dynamics of EV, how to calculate the power and range, and what are the popular EVs available, what about the battery swapping stations, battery monitoring system, and now Sir explained about battery management system. So all these topics are quite helpful, and also they have gave very good explanation regarding how to do that lightweight approach using mRuby. So it's really worthful for all the persons who are really doing their research under this topic. So usually all the FDPs they will concentrate only on the theoretical aspects, but this FDP given a deep insight into the practical aspects, and they have given all the materials as well as how to do programming. So this is quite useful for all of us. So I convey my sincere thanks to all the experts as well as the coordinator of this program, Tyagarajan sir, and all other persons, especially to the HOD of PhD department, Dr. Anantharakshmi ma'am, who has taken efforts to give us all these insights. Thank you very much, all of you. Thank you, ma'am. Thank you for the opportunity given.
Thank you, ma'am. Thank you so much for your valuable feedback, ma'am. It means a lot to us. So these motivate us to do further FDP like this. So I hope everybody has learned from this session many things. Thank you, ma'am.
Yes, sure, ma'am. We are expecting a lot from you in the future.
Thank you, ma'am. Thank you. Yes, ma'am. Kalaivani, ma'am. You want to say anything about this session? You can proceed, ma'am. So now I request all the participants to switch on their video. So let's have a photo session. And after that, the vote of thanks will be proposed. So good evening, everyone. This is Dr. S. Anantalakshmi, head of the Department of ECE and co-coordinator of this FDP session. Now I would like to propose the vote of thanks. It's my privilege and honor to deliver the vote of thanks today for the Atal sponsored 6G online faculty development program on Introduction to MRuby for Electric Vehicle Control Systems, a lightweight approach to battery management organized by Christ College of Engineering and Technology. At the outset, I would like to express our heartfelt gratitude to the AICT Atal Academy for having approved our proposal and granted us the financial support to conduct this FDP. Their encouragement towards capacity building and knowledge enhancement in emerging technologies has been the driving force behind this initiative. I extend our sincere thanks to our distinguished resource persons who had kindly accepted our invitation to share their expertise with us. Their guidance and valuable insights enriched the sessions and help us and helped us to host the program of national importance. I would also like to place on record my appreciation for the program coordinator, Dr. Y. Tyagarajan, Dean, EC and Triple E, and for his meticulous planning, tireless efforts, and unwavering commitment in organizing this FDP. A big thank you goes out to all the participants who have joined us from different parts of the country. Your enthusiasm, engagement, and willingness to learn made this FDP more meaningful. Finally, I extend my gratitude to all the faculty colleagues, organizing committee members, and technical support staff whose behind the scenes efforts have made this event possible. With these words, I once again thank everyone for having spared their valuable time with presence and contributions. Hope all of you had a very good journey with us for this last 6 days and learned a new technology. Thank you. Thank you all once again. So you can take the test up to 6:45. So and after that the link will be that's closed. So try to answer, submit the test, and the feedback link will be given shortly, and you can fill that form also. And
Ma'am, good evening, ma'am.
yes, good evening.
Ma'am, test time it is showing starts at 6:30 p.m. Not 6
sir?
a.m. Not 6:30, 6 p.m. or 6:30 p.m.
So no, I'm not getting your question.
Madam, test timings. No? I
Test
tried to log
timing.
in. Yes, madam. It's showing so starts from 6:30 p.m.
6 up to 6:30 only.
No. So 6:30 it will start, ma'am.
Okay. Sorry. Starts by 6:30 and end by 45 minutes. The time duration is 45 from 6:30 to.
Okay, ma'am. Okay, ma'am.
Okay. Okay.
Hello, ma'am.
Yes, yes, ma'am.
We need to give the test from Atal portal as well as in the group. That
No,
test
no,
link will be
only
there.
only in the link given in the group, ma'am.
Okay, because in Atal portal it is saying it will start at 6:30. Okay, if we are given the test from the group means it is not necessary to give the test again in the Atal portal. No, ma'am.
Yes. No
Okay,
need to.
thank you,
No
ma'am.
need. Yeah, thank you. So, any doubt from the participant side? Any other
Hello,
doubts?
ma'am.
Yes.
Ma'am, I have already completed the test just now, but you said it will start at 6:30. Sure, so should I do the test once again? Because it's saying you've already completed, it is showing for me.
Oh, 1 second, ma'am. Ma'am, no need, ma'am. Already submitted means it will be recorded automatically.
I just
Don't worry.
submitted like a couple of minutes ago, actually.
Okay, that will not be an issue. That is
Okay.
taken as a test submission
So I
only.
need not do another test right now, right?
No, no need, ma'am. No need.
Okay, okay. Thank you, ma'am.
Thank you.
Hello, madam.
Yes, sir.
In link share in a WhatsApp group for test.
Link is shared in the group. You are in which group?
Group 3.
Group 3. Already the link shared in that group. You can check once.
Madam, group 1 not shared, madam.
So let me check, sir.
Please, ma'am.
Sent, sir. You can check once.
Okay, ma'am.
Sent already. So around 5:30 itself he has sent. Check once. So after the test session, the participants are requested to be uh, online, stay online, because we'll be sending you the feedback link by around 6:30. So you'll get the link only at 6:30. So even after, so this feedback is very important. So don't miss that. Then you will not be able to get your certificate. So that is why you have to give the feedback for this last session. That will be sent to you around 6:30, I think. So be online.
Good, sir. How are you, sir?
Hello. Hello, ma'am. Hello. 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 Hello, sir.
Oh, madam, speaker. Hello, yes, sir.
Ma'am,
Yes,
we have to solve the assessment from the Atal portal, or we have to solve the assessment from Google
link, sir.
link which you have sent.
From the
Huh?
link we have given, not title portal. Google Meet.
Okay. Yes, yes. I have to
Google
solve
Meet
it
from
from.
itself.
Okay.
Yes.
જવું છે એમ
અત્યારે પેલું આઈએમપી આપી દેતા તો આઈએમપી લખી લેત ને પછી કાલે સવારે તમે
ઠીક ચાલો આપે ખાલી એક ટેસ્ટ મારે ભરવાની છે એટલે હું આવું
Sir, kindly share feedback link, sir.
સ્કીમિક ટ્રિગર સમજાઈ ગયું સ્કીમિક ટ્રિગર સમજાઈ ગયું એવું
In this video, I will This will really transform your life, your destiny, and it will also transform life people who are surrounding. I will recommend strongly to the people who it will be very, very beneficial to them. This is Sumit Chotai from Baroda. I'm the business of retailing of watches. It is one of the program which I have seen in my life that everyone has goals, but this will really teach you why you want to achieve their goals. What are the characteristics which are needed for these goals? What is your value? What is your system? What are the special relationships that you have? It's just a brief of the program. I would really like to thank Siddharth sir for having such a great program and adding value to us. So I would strongly recommend everyone, given an opportunity, kindly join this program. This will really transform your life, your life. This is the complex power delivered.
ઓકે ચેપ્ટર 1 માંથી ખબર પડી ગઈ પહેલો ક્વેશ્ચન કયો કીધો મેં બ્લોક ડાયાગ્રામ પછી 7 પ્રેક્ટિકલ sorry practical ideal characteristics of operation amplifier ફરીથી બોલું છું બ્લોક ડાયાગ્રામ ઓફ ઓપરેશન એમ્પ્લીફાયર બીજો આઈડિયલ કેરેક્ટરિસ્ટિક્સ ઓફ ઓપરેશન એમ્પ્લીફાયર ત્રીજો જે એક્ઝામ્પલ શો કરાયો હતો એ ચોથો એ ડેફિનેશન ચેપ્ટર 1 કમ્પ્લીટ ચેપ્ટર 2 ક્લિયર ફરીથી બોલું બ્લોક ડાયાગ્રામ આઈડિયલ કેરેક્ટર ઓપરેશન એમ્પ્લીફાયર પ્રેક્ટિકલી આઈડિયલ ઓપરેશન એમ્પ્લીફાયર જે 7 ડેફિનેશન છે ઇનપુટ બાયસ કરંટ ઓફસેટ કરંટ એ બધું બરાબર છે એક એક્ઝામ્પલ an inverting amplifier and non inverting amplifier explain પ્રૂવ કરવાનું v0 is equal to 1 plus rf upon r1 into v in non inverting amplifier v0 is equal to minus rf upon r1 into vs chapter 2 explain difference between practical
ஐடி என்ன ஐடி உனக்கு?
Hello, madam. Hello, madam.
Yes, ma'am.
We have also, can we leave the meeting or should we still stay? Is there anything else to be done?
Photo session. You just video on. No, only photo session, ma'am.
Okay, so after the photo session, we can leave the meeting,
Yes.
right?
Yes, ma'am.
Yes. Thank you, ma'am.
Okay, ma'am. Thank you. Just video on, ma'am. All participants, please switch on your video. Thank you.
And hello, ma'am.
Yes, sir.
No need to fill the feedback form and assessment from Atal portal.
No need, sir. Only link, Google Meet link is enough, sir.
Okay.
No, if want, no, you can also give, but this is sufficient. If you want, you can also give, sir, that will feedback. You can give.
Okay.
Yes, sir.
And what about assessment? Actually, already I have
Assessment only
submitted the
this.
feedback.
No, assessment you
No
can
need
give Google form. Yes, sir.
Google Form. No need from that Atal portal, na?
No, sir. No, sir.
Okay.
Okay, thank you.
Dear participants, kindly switch on your video. We would like to take another photo. Sir. Just hold on for another 1 minute, okay? Vinod Kumar sir. Dr. Vinod Kumar. Dr. Vinod Kumar. Dr. Vinod Kumar sir.
Hello, ma'am. Hello.
Yes.
Yes, sir. Can we let the group?
Yes, sir, you can.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Have a great day.
Prashant.
Thank you, sir.
Where is link? Ma'am, where is feedback link?